I request Srikanth sir and Praveen sir to come onto the dais and occupy their seats. Dr. S. Pradeep, Director of Malnad College of Engineering. I request Dr. Geeta Madam to occupy a seat on the dais. Well, hello and a very good and pleasant morning to each and everyone present here. I deem it a privilege to stand before you and host this inaugural segment of this 2-day international conference on computing technologies and data communication, co-sponsored by IEEE Bangalore section. So indeed, it's a very special occasion for all of us. Why? Because this is the first of its kind where multidisciplines are involved. So there is an involvement of 6 engineering branches: computer science, information science, electronics and communication, electrical and electronics, CSPS and AIML. So all these streams of engineering have joined in organizing this workshop. In that way, it's very special for all of us in the institution. So we are thrilled to have Mr. Watchara, Ruangsang and Mr. Mounesh with us as the chief guests of today's event and speakers. So they are going to speak in the later part of this session. So they are going to share their thoughts, expertise, insights, which definitely benefit majority of the stakeholders of this conference, and you can make use of their expertise and thoughts. So, along with them, we have our management representatives, our Honorable Chairman Sri R.T. Devegowda to witness the occasion, and we have our principal and Srikanth sir, Geeta Madam, and all. So, before we begin, let me take a moment to acknowledge and appreciate the efforts, dedication, and hard work put by the team. Dr. Geeta Madam, Dr. Mohan Lakshmi, Professor Margaret, Professor Dr. Sunita, and Professor Niteshri Madam. So these have put a lot of effort in organizing this program. So let us see the blessings of the Almighty and our tradition for the success of this inaugural event and for the entire conference. So may I call upon Ms. Anisha, student from Computer Science, to render invocation.
ನಿನ್ನ ವಾನರದಂತೆ ನನ್ನ ಮನವಿರಲಿ, ನಿನ್ನ ಸಾಗರದಂತೆ ನನ್ನ ಎದೆ ಇರಲಿ, ನಿನ್ನ ವಾದಳದಂತೆ ನನ್ನ ಮನವಿರಲಿ, ನಿನ್ನ ಸಾಗರದಂತೆ ನನ್ನ ಎದೆ ಇರಲಿ, ನಿನ್ನ ವಾದಳದಂತೆ ನನ್ನ ಮನವಿರಲಿ, ನಿನ್ನ ಸೋಕಿಯ ತೆರದಿ ನನ್ನ ಸೊಬಗಿರಲಿ,
kickstart to this international conference. I now request Professor Nityashri R, Assistant Professor, Department of Computer Science and Engineering, and organizing co-chair of this international conference, to deliver the welcome address. Good morning, everyone. It gives me immense pleasure to welcome you all to the International Conference on Computing Technologies and Data Communication, ICCTDC 2025, proudly hosted by Malnad College of Engineering, Hassan. On behalf of the organizing committee, I extend a warm and heartfelt welcome to our chief guest, our distinguished guest of honor, and all our invited dignitaries. A very special welcome to our keynote speaker, Dr. Watchara Ruangsang from Mongkut University of Technology, Thailand. We welcome you, sir. I also extend a special welcome to our keynote speaker, Mr. Mounesh, Senior Data Engineer at Capgemini India Private Limited, Pune. Welcome, sir. It is an honor to welcome Shri R.T. Devagowda, sir, Honorable Chairman of MTEs. Your presence adds great value to this international conference, and we are grateful to you. Welcome. It's a privilege to welcome Shri C.R. Jagadish, Honorable Secretary of MTEs, to the inaugural ceremony. We are honored to conduct this conference under your leadership. Welcome, sir. In their absentia, I welcome Shri Arjun Gurudev, sir, Honorable Vice Chairman, MCE, and Shri H.D. Pashwanath, sir, Treasurer, MTEs. A warm welcome to our beloved Principal, Dr. A.J. Krishnaya, sir, Malnad College of Engineering. Welcome, sir. I extend my heartiest welcome to Dr. S. Pradeep, sir, in his absence. I take this opportunity to welcome Dr. P.C. Shrikant, sir, IEEE Student Batch Counselor, MCE. Welcome, sir. A special welcome to Dr. Geeta Kiran A, Dean Corporate Affairs and Organizing Chair of ICCTDC 2025, whose vision and tireless efforts have played a central role in the successful planning and execution of this event. Welcome, ma'am. I also welcome Hassan Ramchandran, Australian Visa and Migration Consultancy Services, Sydney. Welcome, sir. A warm welcome to the organizing department heads, Dr. S. Rajana, sir, HOD EEE, Dr. Padmaja Devi, madam, HOD ECE, Dr. J. Chandrika, madam, HOD Department of CSE. In his absentia, I welcome Dr. Anand Babu J, HOD Department of ISE, Dr. Balaji Prabhu, sir, HOD Department of AIML, and Dr. B. Ramesh, sir, Department of CSPS. I also extend my welcome to all the deans, HODs of various other departments, the academic leaders of MCE who continue to support and uplift every initiative. I also extend a heartfelt welcome to all the participants from institutions across India and abroad who have joined us virtually, and also to our student delegates and to the media person. Welcome you all. Let this ICCTDC 2025 serve as a platform for idea exchange, innovation and collaboration. I wish everyone a highly successful and enriching conference experience. I welcome one and all. Thank you, sir.
Thank you, Nitya, for your warm welcome address. So now we are going to know something about the conference, how the idea generated, what the conference is all about, why this topic, why multidisciplinary, and so on. So now Dr. A. Geeta Kiran, the chair of this conference, is going to throw light on the conference and also to release the conference proceedings.
Respected dignitaries on and off the dais, deans, heads of the departments, faculty members, organizing co-chairs, session chairs, authors, and my dear students. A pleasant morning to one and all. It's an immense pleasure for me to extend a warm welcome to all the dignitaries here who made this event happen. Yeah, the whole, as Sir told, the whole journey, I can say this moment marks the beginning of a year-long journey that started from the application to IEEE in 2023 and approval in March 2024. For this, I need to extend my thanks to Dr. S. Pradeep and Dr. A.J. Krishnaya, who supported me in initiating this work. My wholehearted thanks to MTES, all the directors of MTES, special thanks to R.T. Devegowda sir, chairman of MTES, and Shri C.R. Jagadish, secretary of MTES, Hassan. As I told, ICCTDC 2025 is the first of its kind interdisciplinary conference which has been uniting the 6 departments at our institute. Which 6 departments? Electrical and Electronics Engineering, Electronics and Communication Engineering, Computer Science and Engineering, Information Science and Engineering, AI and ML and CS/BS. We together are hosting this conference at our institute. We have received totally for this conference the research submissions were really overwhelming. That is 2,396 research submissions were received. Among them, with the support of the reviewers, the number of reviewers were 429. So, with the support of 429 reviewers, we have come down to the acceptance of 423 papers. So, we have totally accepted 423 papers out of 2,396 papers which had been submitted, which marks the highly committed 12% acceptance. Moving ahead, we had 5 tracks. The first one was Data Science and Engineering, Computational Technology, Computational Intelligence, then Signal and Image Processing, Communication and Networking tracks which we received. And among them, this was the summary what I gave the total number of papers. So I humbly request each one of the young innovators to come forward, work with curiosity. Always research starts with curiosity, it grows with hard work, and it will strengthen only when we work together. So I beseech each one of the young innovators to work on the problems, that is real life problems. Not only working the research, working or doing some research which adds knowledge to you. It should be something beneficial to the society. So I urge each one of you to look into the real life problems and benefit to the society. Yes, with this, I welcome each one of you and cherish the whole day. Thank you.
Thank you, ma'am. Thank you for giving the insights and overview of ICC 2025. So we are in an important milestone of the conference today. I request all the dignitaries on the dais to please step forward and unveil the official proceedings of ICCTDC 2025. So these proceedings will be submitted to IEEE for inclusion in the IEEE Explore Digital Library, which is indexed by Scopus. And all the submissions which are presented today will be published in IEEE Digital Explorer. I request all the dignitaries to please step forward.
HDMI ಲೈಕ್ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ದೀರಾ ನಾ ಬುಕ್ ಸರ್ ಬುಕ್ಕು ಸರ್ ಬುಕ್ ಈ ಕಡೆ ಫ್ರಂಟ್ ಸರ್ ಹೇಳ್ಬಿಡು ಫ್ರಂಟ್ ರೆಡಿ ಸ್ವಲ್ಪ ಎಲ್ಲ ಕ್ಲೋಸ್ ಆಗಿ ಸ್ವಲ್ಪ ಹಾಗೆ ರೆಡಿ ಚೂರು
Dr. A.J. Krishnaya, Principal, MCE Hassan, to address the gathering.
Wait. ಲೇಟ್ ಆಯ್ತು ಚಾರ್ಜ್ ಆಗ್ತೈತೆ ಹೆಂಗೆ ಮಾಡ್ಬೇಕು ನಾನು ಬಿಟ್ಟವಲ್ಲ
Good morning to one and all present here. Respected dignitaries on the dais, the Honorable Chairman of MTS, Sri R.T. Devagowda sir, Honorable Secretary, Sri C.R. Jagdish sir, the guest of chief guest of today's the international conference, Dr. Watchara Ruangsang, and Mr. Mounesh, and the Dr. Srikant, HOD of the NC department, all the head of department, deans, so professors, so teaching and non-teaching faculties, and dear participants. Welcome you all to the International Conference on Computing Technologies and Data Communication, ICCTDC 2025. This international conference reflects our institution's focus on research, innovation, and global engagement. We are honored to host such a prestigious gathering that promises not just academic exchange, but also the potential to drive changes in real world context through computational and analytical intelligence. ICCTDC 2025 is a proud initiative that brings together 6 of our engineering departments, adding credibility to each of the department's records. The impressive number of paper submission, as highlighted by Dr. Geeta Kiran stands as the testament of the conference global reach and relevance. We are delighted to have distinguished speaker Dr. Watchara Ruangsang and Mr. Mounesh joining us to share their insights and experience, adding great value of the event. I take this opportunity to place on record the sincere and tireless effort of Dr. Geeta Kiran, Dean Corporate Affairs and Organizing Chair, for her vision and leadership in exchanging this conference. I also appreciate the effort of all organizing co-chairs, session coordinators and organizing committee members for their commitment and collaboration in making International Conference on Computing Technologies and Data Communication 2025 a grand success. This conference is more than the schedule of a paper presentation. It is a space for networking, ideation and meaningful research outcomes. I encourage all participants to actively engage, learn and contribute to their futures in computing technologies and data communication. Wishing you all a success and enriched conference. Thank you.
Thank you, sir, for addressing the gathering and appreciating the efforts of the organizing committee and wishing all the best for the successful completion of this international conference. So now it is the time for formal inauguration. So Deepa Pragatiya Sanketa antella kelidivi. Lamp is the symbol of progress. So now we are going to formally inaugurate this conference. I request all the dignitaries on the dais to light the lamp and inaugurate it.
madam, photo. One photo. Okay, sir. Ready, sir. Ready. Good, yeah. 1 second, sir. Sir, thank you.
Thank you all. I invite Dr. H.L. Prakruti, Associate Professor, Department of Electronics and Communication Engineering, to formally introduce our chief guest.
A very good morning to one and all present here. So it is my immense pride and a genuine delight that I stand before you to introduce an exceptional scholar and a visionary technologist and a true catalyst in the field of the digital innovation, Dr. Watchara Ruangsang. So Dr. Watchara is presently a lecturer in the media technology at the School of Architecture and Design, the King Mongkut University of Technology, Thailand. He is the chair of the IEEE Thailand section Young Professional. He is having a doctorate in the electrical engineering from the prestigious Chulalongkorn University. So on the real-time image super resolution for the FPGA-based system, and he has showcased his ability to blend the theoretical depth with practical application. He also includes a master's in the electrical engineering from the same university and the bachelor's degree from the Keynote, so not Bangkok. He is the research creator, spans across the digital image and the video processing, embedded system design, and the computer vision and artificial intelligence for the medical diagnosis. And he has been a core contributor over the 10 million nationally funded research projects, and it is accounting to more than the 9 billion that I got. He is having a 17 peer-reviewed publications in the IEEE journals and conferences, and he is having a 7 national patents covering the inventions in the super resolution imaging, the contentless, the health diagnostic, and artificial intelligence-based vision system. He is a proud recipient of the multinational, international accolades, which includes the gold and silver medals from the Geneva International Exhibition of Inventions. So Dr. Watchara Ruangsang embodies the spirit of academic brilliance, technological curiosity, and unwavering dedication to the society. His achievements are unfathomable. So I request everyone to join your hands to welcome our Dr. Watchara Ruangsang. I welcome you, sir. So I request sir to address the gathering.
Okay, good morning everyone. I'm Watchara. I'm glad to be here and join like the keynote speaker. And as my keynote speaker, I will present about the medical AI and trend in 2025 and cover with my area super resolution. Thank you to everyone to join.
Thank you, sir. So it's a great honor to have Mr. Mounesh with us. So he's currently working at Capgemini India as a senior data engineer with around 8 years of IT experience and 4 years in academics. Previously, he has served as data engineer and delivery head for data science and cloud platform projects at Bluesight, a US-based healthcare company recently recognized among the top 10 health companies in the USA. He is a visionary leader who bridges industry innovation with academic excellence. He has strong expertise in big data, AI, ML, and cloud-based data platforms, especially in healthcare and finance domains where scalability, compliance, and data integrity are critical. His technical expertise include big data technologies, programming languages like Scala, PySpark, Python, Flask, cloud tools, AWS, ETL, ML pipelines. He is specialized in end-to-end data pipeline development and AI ML integration. He has conducted over 110 plus interviews in big data, Spark, Scala, PySpark, Data Science and Python. He is the technical panel lead for recruitment and talent acquisition in financial services. He is associated as a third-party technical recruiter for multiple companies and consultants. He was a former UGC approved professor at Shivaji University, Kolhapur, associated with reputed training institutes in Pune, published research papers in Elsevier and other international journals on applied ML and big data, delivered 25 plus technical talks and webinars on topics such as research methodologies, data science and big data systems. He holds an MTech degree in computer science from Gopte Institute of Technology, Belagavi, and BE in computer science from ELDA CET, Vijayapura. A very warm welcome to you, sir. We are honored to have you on the stage with us.
Respected dignitaries on the dais and off the dais. So, as per the introductions given, so let us. There is not nothing is there to talk on that. Everything is put on the stage. So the only thing is rest of the sessions I will go through the various of the trends, not with the books what we have, but a lot of things to discuss on that. So I conclude my words. Thank you.
Thank you, Mounesh, for your warm address. So now I request our Honorable Secretary, Jagdish sir, to address the gathering.
ಇಂದು ನಮಗೆ ಒಳ್ಳೆಯ ಸುವರ್ಣಾವಕಾಶ. ಅಂತಾರಾಷ್ಟ್ರೀಯ ಒಂದು ಸಮ್ಮೇಳನವನ್ನು IEEE ಮತ್ತು ಕಂಪ್ಯೂಟರ್ ವಿಭಾಗದ ವತಿಯಿಂದ ವಿವಿಧ ದೇಶಗಳಿಂದ ಬಂದಂಥ ಸಂಪನ್ಮೂಲ ವ್ಯಕ್ತಿಗಳ ಮುಖೇನ ಉದ್ಘಾಟನೆ ಮಾಡ್ತಕ್ಕಂತಹ ಒಂದು ಕಾರ್ಯಕ್ರಮ ಯಶಸ್ವಿಯಾಗಲಿ ಅಂತಕ್ಕಂಥ ಮುನ್ನುಡಿಯೊಂದಿಗೆ ನಮ್ಮ ಹಿರಿಯರು, ಈ ಸಂಸ್ಥೆಯ ಅಧ್ಯಕ್ಷರು, ಸಮಾಜಮುಖಿ ಚಿಂತನೆಯ ವ್ಯಕ್ತಿಯಾದಂತಹ ನಮ್ಮೆಲ್ಲರ ಹಿರಿಯರು ಆದಂತಹ ಆರ್.ಟಿ. ದೇವೇಗೌಡರ ಅಧ್ಯಕ್ಷತೆಯಲ್ಲಿ ಈ ಒಂದು ಸಮ್ಮೇಳನ ಇಂದು ಮತ್ತು ನಾಳೆ ನಮ್ಮ ಕಾಲೇಜಿನಲ್ಲಿ ನಡೀತಾ ಇರ್ತಕ್ಕಂಥದ್ದು ನಮ್ಮೆಲ್ಲರಿಗೂ ಹೆಮ್ಮೆಯ ವಿಷಯ. ಇಲ್ಲಿ ಅನೇಕ ದೇಶಗಳಿಂದ ಆಯೋಜಿಸಿರ್ತಕ್ಕಂತಹ ಈ ಒಂದು ದೊಡ್ಡ ಸಮ್ಮೇಳನದ ಪ್ರಮುಖ ವಿಭಾಗಗಳಾದಂತಹ E&E ಇರ್ಬೋದು, E&C ಇರ್ಬೋದು, CS ವಿಭಾಗದ ಕಂಪ್ಯೂಟರ್ ಸೈನ್ಸ್ ಮತ್ತು CSBS, AI ವಿಭಾಗದ ಎಲ್ಲ ಕಾರ್ಯಾಗಾರಗಳನ್ನು ಈ ಒಂದು ಸಮ್ಮೇಳನದ ಮುಖಾಂತರ ತಂದು ಡೇಟಾ ಸೈನ್ಸ್ ಮತ್ತು ಕಂಪ್ಯೂಟರ್ ಸೈನ್ಸ್ ವಿಭಾಗದಲ್ಲಿ ಯಾವ ಟೆಕ್ನಾಲಜಿಗಳನ್ನು ದೇಶಕ್ಕೆ ಕೊಡುಗೆಯಾಗಿ ನೀಡಬಹುದು, ಈ ಒಂದು ಕೊಡುಗೆಗಳು ಯಾವ ರೀತಿಯ ನಡೀತವೆ, ಈ ಒಂದು ಮಲ್ನಾಡು ಕಾಲೇಜಿನ ವತಿಯಿಂದ ನಡೀತಾ ಇರ್ತಕ್ಕಂತಹ ಈ ಒಂದು ಸಮ್ಮೇಳನ ಭಾಳ ಉಪಯುಕ್ತವಾದಂತಹ ಸಂದೇಶವನ್ನು ಕೊಡುವ ಮೂಲಕ ದೇಶಕ್ಕೆ ಮತ್ತು ರಾಜ್ಯಕ್ಕೆ ಮಾದರಿಯಾಗುವಂತಹ ಒಂದು ಶಕ್ತಿಯನ್ನು ತುಂಬಿ ಈ ಸಮ್ಮೇಳನ ಯಶಸ್ವಿಯಾಗಲೆಂದು ಹಾರೈಸಿ 2 ದಿವಸ ಕಾರ್ಯಾಗಾರದಲ್ಲಿ ಈ ಒಂದು ಕಾರ್ಯಾಗಾರದ ಎಲ್ಲ ವಿಚಾರವನ್ನು ನಮ್ಮ ಕಾಲೇಜಿನ ಪ್ರಾಧ್ಯಾಪಕರುಗಳು ತಿಳ್ಕೊಳ್ಳುವ ಮೂಲಕ ವಿದ್ಯಾರ್ಥಿಗಳಿಗೆ ಜ್ಞಾನಾರ್ಜನೆಯನ್ನು ಮಾಡುವ ಮೂಲಕ ದೇಶ ಕಟ್ಟುವಂತಹ ಕೆಲಸಕ್ಕೆ ಅವರ ಒಂದು ಕೊಡುಗೆಯನ್ನು ನೀಡಲಿ. ಇಂಥ ಒಂದು ಕಾರ್ಯಕ್ರಮದಲ್ಲಿ ಭಾಗವಹಿಸಿರ್ತಕ್ಕಂತಹ ಸಂಪನ್ಮೂಲ ವ್ಯಕ್ತಿಗಳಿಗೆ ಹಾಗೂ ಈ ಒಂದು ಕಾರ್ಯಾಗಾರದ ಅಧ್ಯಕ್ಷತೆಯನ್ನು ವಹಿಸಿರ್ತಕ್ಕಂತಹ ಗೀತಾ ಕಿರಣ್, ಇದರ ಅಧ್ಯಕ್ಷತೆಯನ್ನು ವಹಿಸಿ ನಮ್ಮ ಮಲ್ನಾಡ್ ಕಾಲೇಜಿಗೆ ಶಕ್ತಿಯನ್ನು ತುಂಬಿದ್ದಾರೆ. ಅದೇ ರೀತಿ IEEE ವಿಭಾಗದಲ್ಲಿ ಡಾಕ್ಟರ್ ಶ್ರೀಕಾಂತ್ ಅವರು ಈ ಒಂದು ವೇದಿಕೆಯ ಮೇಲೆ ಉಪಸ್ಥಿತರಿದ್ದಾರೆ. ಅವರಿಗೂ ಸಹ ನಮ್ಮ ಕಾಲೇಜಿನ ವತಿಯಿಂದ ನಾನು ಅಭಿನಂದನೆಗಳು ಸಲ್ಲಿಸ್ತೇನೆ. ಇದಕ್ಕೆ ಅವರು ಪ್ರಮುಖ ರೂವಾರಿಗಳಾಗಿದ್ದರು ಈ ಹಿಂದೆ. ಈಗ ಅವರ ಸ್ಥಾನವನ್ನು ಪಂಕಜ ಅವರು ವಹಿಸ್ಕೊಂಡಿದ್ದಾರೆ. ಅದೇ ರೀತಿ ನಮ್ಮ ಕಾಲೇಜಿನ ಸ್ಫೂರ್ತಿಯಾದಂತಹ ಡಾಕ್ಟರ್ AJ ಕೃಷ್ಣಯ್ಯನವರ ಸಾರಥ್ಯದಲ್ಲಿ ಇದು ನಡೀತಿರ್ತಕ್ಕಂಥದ್ದು ನಮ್ಮೆಲ್ಲರಿಗೂ ಹೆಮ್ಮೆಯ ವಿಚಾರ. ಈ ಒಂದು ಅಂತಾರಾಷ್ಟ್ರೀಯ ಸಮ್ಮೇಳನ ಯಶಸ್ವಿಯಾಗಿ ನಡೆಯಲಿ ಎಂದು ಶುಭ ಕೋರ್ತೇನೆ. ಈ ಒಂದು ಕಾರ್ಯಕ್ರಮದಲ್ಲಿ ಕರೆದು ನಮ್ಮನ್ನು ಮಾತನಾಡಲಿಕ್ಕೆ ಅವಕಾಶ ಕೊಟ್ಟಂತಹ ಈ ಅಂತಾರಾಷ್ಟ್ರೀಯ ಸಮ್ಮೇಳನದ ಅಧ್ಯಕ್ಷರು ಹಾಗೂ ಸಂಪನ್ಮೂಲ ವ್ಯಕ್ತಿಗಳಿಗೆ ವಂದಿಸಿ ನನ್ನೊಂದೆರಡು ಮಾತುಗಳಿಗೆ ವಿದಾಯ ಹೇಳ್ತೇನೆ. ಜೈ ಹಿಂದ್, ಜೈ ಕರ್ನಾಟಕ.
Thank you so much, sir. So to add to sir's thoughts, we have received around 20 representations from 24 countries, including USA, the Philippines, Malaysia, China, Sri Lanka, and more. And across 22 Indian states from Tamil Nadu, Karnataka, Kerala, Maharashtra, and many more. So this contribution and these representations of research articles shows like how well Malnad College of Engineering is connected across the globe. Thank you, sir. So now I request Shri R.T. Devegowda sir to render the presidential remarks.
Respectable dignitaries on the dais, off the dais, of all the deans, professors, and my dear students. It is a landmark of our institution. It will be a special thanks to Dr. Geeta Kiran and her party to having arranged such a wonderful and useful conference in our college. We have seen many colleges, but our college is achieving more in this field. For that, all the deans, professors, and the staff are responsible. And my request, this conference will be one of the boost to the institution and also to the useful to the students. I request all the participants to have a wonderful conference on this occasion. I wish this conference have a success and useful to the institution. Thank you. Thank you.
Thank you, sir, for your motivating words, and also thank you for wishing for the success of this conference. So now we have come to the end of this inaugural segment of this today's international conference. I request Dr. Nandita, Dean, Academic Affairs, to render a vote of thanks.
A very good morning to one and all. I deem it a privilege to propose the vote of thanks on this auspicious occasion of the inaugural ceremony of ICCTDC 2025. Firstly, I would like to thank our Honorable Chairman of MPES, Shri R.T. Devegowda sir, for gracing this occasion and delivering the presidential remarks. Thank you, sir. I would like to extend my heartfelt thanks to our Honorable Secretary of MPES, Shri C.R. Jagdish sir, for his gracious presence on this occasion. Thank you, sir. I extend my heartfelt thanks to our chief guest, Dr. Watchara from King Mongkut's University for gracing this occasion and sharing the valuable insights. Thank you, sir. I take this opportunity to thank our keynote speaker, Mr. Mounesh K, Senior Data Engineer at Capgemini Private Limited, Pune, for gracing this occasion. Thank you, sir.
I request Sri R.T. Ravegoda sir to give away the token.
I am deeply thankful to our respected principal, Dr. A.J. Krishnaya sir, for the inspiring words and for his constant support and encouragement. Thank you, sir. I thank Dr. P.C. Srikanth sir, the MCE IEEE Student Branch Counselor, for his gracious presence on this occasion. Thank you, sir. I thank Dr. Rajana sir, HOD of IEEE Department, for gracing this occasion. Sir, please. I thank Dr. Padmaja madam, the HOD of ENC Department, for gracing this occasion. Thank you, madam. I thank Sri Harsha Ramachandra for gracing this occasion. Thank you, sir. I take this opportunity to thank the session chair, Dr. Bharati, Professor and Head of Department of MCA, JSS University, Mysuru. Please, ma'am. I request Geeta Kiran, Jagdish sir, to do the honors. I extend my heartfelt thanks to another session chair, Dr. Vinuta MR, Professor and Head of Department of AIDS, Naukis College of Engineering, Hassan. Thank you, madam. Please. I request Sri R.T. Ravegoda sir to do the honors. I thank Sri Uday Kumar, reporter, Indian Express, for gracing this occasion. Thank you, sir. I also thank Srinivas, press reporter, Hassan, for gracing this occasion. Thank you, sir. I take this opportunity to thank all the session co-chairs, session coordinators, and the organizing committee members for their seamless efforts in conducting this event successfully. I thank and a special note of appreciation to Dr. A. Geeta Kiran, the organizing chair of this event, for her dedication and leadership in making this conference a reality. Thank you, madam. I extend my heartfelt thanks to all deans, HODs, faculty members, student volunteers, guests and delegates who have joined us and contributed to the success of this ceremony. I thank the present media for their presence on this occasion. Finally, I would like to thank all those who have directly or indirectly involved in the successful organization of this conference. Thank you. Thank you, Ananda.
Thank you, Nandita ma'am. Thank you for accepting our invitation to deliver the vote of thanks on this occasion. So, I request all the session coordinators to please come near the dais so that we can have a group photo. Session coordinators of both online and offline. Chaitra madam. Nandita ma'am. Malnad ma'am. Uma ma'am.
All the session
coordinators. Arjun sir.
Deepak.
I request all the participants to please stay back. Kaveri ma'am, Kruti ma'am, Pratima. I request all the session coordinators. I request all the faculty members to please stay back. All the faculty members please stay back. Faculty members please stay back.
ಬನ್ನಿ ಬಂದವ್ರೆ ಸುಧೀರ್ ಜೈನ್ ಒಂದು ಸುಧೀರ್ ಜೈನ್ ಬನ್ನಿ ಓಕೆ ಸರ್
So I am researcher at Chulalongkorn University under research unit MDAP, and also I am chair of IEEE Young Professional Thailand 2025. And today I will give a talk about artificial intelligence in medical application, trend and innovation 2025. But I have time only 20 minutes. I will try to share what is the trend cover with my research. I hope it's useful for all of you. And topic for today, I will present about the current AI trend. What is the 2025, what is the current AI trend in healthcare technology and deployment. And also medical AI, according image and diagnostic specialist in terms of the brain and the mammogram. You will see some application. But almost come from the academic area, and I focus on the research. Maybe this slide is focused on the research. You will get some idea to your work. You can apply and continue to your work. And also, I will talk about my research, contribute, technical implement, and future direction. And first of all, as you see in the curve, today in 2025, right? And maybe you know all of the generative AI is like the Gemini, ChatGPT, and called that is called the generative. And from the research, it's proved 85% in terms of the healthcare is achieved the generative AI already to help many parts of many areas. And also 64% is report about the positive reason from the user. It's good if we use the generative AI to help. And also in terms of the market, you will see 17.2 million market is grown up, and also the 1,000 of FDA approved AI device in the medical area. And also the productive is a lot of the solution. And nowadays 2025 is area of the research. And for the implement of the AI, for nowadays, 40% is reduced for the document or the routine work is reduced by the AI repeat. And also we use the AI for the predictive analytics to in terms of the healthcare. And then synthesis data generation. That means you know the all of data in terms of the AI is very important. We need to good data and clean data to train with the AI to get high accuracy, high performance. That is the point. And also we have many points like the sharing, learning, and high responsibility. And as this picture, I think for me is the future in terms of digital twin. Digital twin, we have two sides like the physical layer twin. Physical layer means the real world, and also the digital twin side is look like the simulation. As nowadays we have the hardware ready and all of environment ready to simulate about the healthcare by the digital twin. That means same information or interact information between physical layer and digital twin layer. You can simulate something in the simulation side, right? Before you test in real case or try to implement something. That is the future. And also for nowadays, as we have the many real-time monitor and also the regulator campaign with the people change the control plan. That is also the plan. And in terms of the healthcare, for the data is the perfect match with the AI. Because as you know, all of the world, 30% of the global data is generated by the
generated by the healthcare system, like the face or the movement or many inmates and the log of the treatment healthcare. And also the 80% unstruck data is include inmate note lab report. And also the time sensitive, that is the need some emergency environment. And also deep learning or the AI, deep learning in AI is excellent. And as you see this one, example in terms of the neuron in brain, we can have many data. That's why the AI is matched with the healthcare area. That is the future direction, and for nowadays, what in terms of the research, healthcare, what they do, what we try to do, what we try to solve. And also, this is some case of the example. Before this one, as you see the AI mammography, that is usually 6 minutes, right, to try to predict and to try to warning and to predict in future you will have the cancel or not cancel. For now, in terms of the research can prove and show this performance already. And also for nowadays, for this system, we can have like a 94% accuracy. You see, the accuracy is very high. And we have the system etiquette already. And another application in neuron, right? In neuron, I want you to see, in terms of the AI, we have mixed the data already and try to learn and extract some good feature by many ways of the research, like the CNN, ANN, SVM, and random forest logistic regression. That is, you see for now that we use many data to learn. Previous one and long time ago, we use only one data per time, only image. And for now, we can have like the multi-data dimension or multi-model data dimension. That is the point. And also in terms of the lab like the pathway, this area. And AI also come to this area to help like the expert level accuracy to detect the cancer, to predict that tissue base is what happened in that one. And also automate cell counting, that is very important to counting cell, how amount of the cell, that one. And also the early infection detect. I think soon we will have many systems to see that one about the early infection detect. Come to the in part of my research. This is our team research in 2024 at the Chulalongkorn University. Actually, we start from the video technology research group, and then we try to set up over to research unit. We have the advisor, Professor Thonburi, along with she also chair of IEEE Thailand section. And you see, our group is also international student. Maybe you have chance, you can try to email to her to try to study at Chulalongkorn University in future. And also, as you see, almost that one, before you get data, that means you have to data as you have must be good, right? If data good, the model is predict or classify is good. But in terms of this one, sometime or some case AI see beyond pixel to that one, data set is learning. What is the point? Our research is to do about image super resolution. Image super resolution is from this program. If the person, object or image too far off the camera, we will have the low resolution or low size, right? If we enlarge it or increase resolution, resolution is going to blur, not clear, as in the example, right? And this is the real scenario in terms of the research. We come to image super resolution. And some example, this is like the use for the Google AI recognition. If we use the low resolution image, you will see the performance of the recognition is to be 50 or 60%. But if you apply like the image to clear, you can see the performance go to the 92%. That means that data is important. Also, pre-processing is very important. That is the point for super resolution will help for this case. And also, this is the story of the super resolution start from long time ago, 1970, with the interpolation based, reconstruction based, and also learning based. On my time when I study PhD, I'm under this one, convolution based. But nowadays, you see the curve from 2015 and 2012, 2022 till now, we change and a lot of the model based on the transformer based in terms of the AI. And you can see the accuracy in terms of PSNR. If high, that means that image, the result of image is very good. That is the point for the image super resolution. And then the basic of the super resolution in terms of the CNN, we will have the low resolution, right? And then we enlarge or increase the resolution by maybe by qubit or something, and then extract the feature, what is the detail of the head in eye, in mouth, or in ear, and then use the nonlinear mapping and reconstruct it to produce the high resolution. And then our group research is cover of what kind of the image, like we first start of the general image. This is some result, and also we go into the face image, like the scale 8 times and 16 times. Mean this one how if we have the low resolution only 16 by 16 and we want to enlarge it to 128 by 128, you can see very low side and high side. And also we cover with the medical imaging area and other research like the remote sensing is from the satellite, and then for the architecture and also video and compression try to reduce the data. That is all of our group work on the super resolution. And some of the research, we start from 2019. We first use the same idea as the basic of the super resolution, this one feature extraction, but we try to propose and reduce the size of the model, and we compare with the other state of the art. You will see is we can call by qubit is the input of the image. We try to enhance and increase resolution to this part. This is all of my work. And then indicate which I present before about the if model get this one to learn, that means the accuracy of model is not good, right? If we use this one, it will be more good. And also we also try to reduce the number of parameters, and then still have the PSNR is too high. This one you see the good result, right? From the low resolution, this one we can reconstruct back into to have the image for this area. And then in 2020, we try to One thing in terms of the AI, we work on the loss function or objective function, trying to propose the loss function, how to improve it. And very important is about this one. The some image is already gone, right? We try to reconstruct that, and you can see. That means two or three of these work, the performance good in terms of the age and the line of the image. That is the performance of our model. And then this is my work when I study PhD. Actually, my work is focused for the lightweight image resolution. Lightweight means, for now, the model, if the size of the model is really big, that means accuracy should be good, right? But the point when you processing with the hardware like the GPU, if the GPU support to high size of the model, that means you have to pay a lot, and some case is no need. That's why I try to optimize the model to larger model to the small model that is called the lightweight. In this work, I try to minimize some bug inside of the baseline. And then, as I found, this is the baseline model. It's produced very good, right? But in terms of the general, in terms of the real data, you see the reference baseline is fake the data. That means the line of this one is bigger than real data. Real data is here mean the high resolution image. But in my work, you can see I can produce the data look like the high resolution. That is target of my work. And also after that, we try to apply like the script excitation for single image super resolution. That is all in terms of the general image. After that, we think if we still work with the general image, that means this kind of the general image, right? Is we have to find the end user who will use our research or who will use our algorithm. After that, we will focus more on the text, right? Text this one. Because we think that text information is the image is very important. After that, in 2023, we try to cover more and start to do about the attention base. Attention is inside the transformer base. Is the one model for the AI in terms of the super resolution. And then this is the first work we work. As I tell before, we try to find the end user for our research work, and we try to work with the medical area. But so sorry, you will not see this. This one is the endoscope, and we try to enhance the image detail to reconstruct. You will see in terms of the PSI, we getting high. From 42, we get the 44. That is improved a lot. And then we also do in the face. This is what I tell. Actually, with low resolution 8 by 8, we can enlarge it and apply the super resolution to be something like this. This is the one cover area. That's why the many generative AI can reconstruct from the very low resolution. And this is our work. And also this is some work of the medical area. I think my time is close to it. I should skip this almost this one, right? We try to improve in terms of the PSI to see if we use the robot, right? And then the image is clear that help doctor to classify it. That is the point. And for the research to practice in future. It is the 10 challenge and solution for the future. The important is the data set is different. You have to classify and label of the data, and soon algorithm will be improved, and also integrate with the complexity, and also multi-site validate, and also healthcare professional training. And today I share some knowledge to you. And then at the point of the future direction, the important is the one with the foundation model. You will see the model is improve. I suggest you, before you do the research, give some time to the review and try to check state of the art. And also this one, what I tell the multi-model mean integrate with the text, image, and lab data to get more and high performance. And also, as I tell about before, the digital twin will repeat some work and research. And also, this one is in terms of the data, the technology of the data to get the data used. The technology is improved a lot. We can have many kind of the good data already. And for the conclusion, that is the healthcare in the future, we will focus on the production deployment and also return focus adaptation. And as my work, the image enhancement still want to work with this area. And also, this is all of my presentation. Thank you for listening me. Yeah, I hope it's useful for you. It's okay? Right. Do you have any question? No, right?
Thank you, sir. Now we have Dr. Mounesh, who will be talking on industry applications on big data and AI. So over to you.
Okay. Good morning, all. So, firstly, I don't have any of the fancy stuff PPTs over there to present, and I'm having the slides. Without slides, I can deliver more. But my research and whatever the things I'm working on, especially before the 5-6 years, I was working on the healthcare sector, which you can check on the internet, the website, which is the third most company in the world, especially in the US. And currently, I'm working as a senior data engineer and a senior consultant in the Capgemini research and development wing. So the main area of focus is basically on the finance as of now, but I have extensively worked on many of the tools and technologies and tech stacks. And not with the image processing, my area of expertise. And in code, we have that we can say that time is very important, right? But nowadays, the data is very important. I'm having some of the slides. I can easily differentiate without learning any ML, any GenAI, because we are working on the GenAI currently, and we are working on the ML models currently. And before that, I worked on many of the big data application things, which is the catalyst to the ML actually. And after your whenever we say the data scientist is what? Just it is having 4 to 5 lines of code. It is just you are writing unsupervised, supervisor, or reinforcement. Correct? These only you are writing just 4 to 5 lines of code. And to this code, what you are getting the data? You are getting some ready-made data sets. Most probably the diabetics and Titanic shape, or one more is there, right? Leaf something, flower. The very famous data set is there, where you are getting down. Correct. That is one. So whenever I go to evaluate any of the papers, any of the colleges, anywhere, only on 3 data sets I used to see the projects, and with the Jupyter notebooks. And the things will not work like this in the industries, because before, when I started my career in 2012, I was there in the field of academics at 4 years. But whatever the things we are doing in the academics, the same, I was also taught the big data Python, but that time ML was not in the trend. But what we are working is totally different. So that? Okay. So here, can you go to the slide? So these are my area of expertise. If you are having any questions at any point of the time, you can ask me the questions. And I don't have any of the agenda here because I'm not going through this step by step. Because it's a boring one, right? You all know. Whatever the agenda we prefer, we are never do that. Nobody is perfect here. So in today's session, with a less amount of time, just we talk on whatever the industries, applications are going on, how the industry is taking up whatever the subjects or whatever the syllabus there in the academics, especially in the big data AI, GenAl. There will be recent trend is GenAl. So to that, these are my tech stacks. Extensively working on these tech stacks. Apart from that, I don't know anything. I don't know Java. I hate Java because very complex things are there in Java. If you come to Python, if you come to Scala, if you come to R, if you come to Spark, lot of things can be solved, but not with the Java. But still the jobs are there, and many of the trends are saying AI will take the jobs. It will take the Java jobs. Not the DS, big data, Python, cloud, or Spark, Scala, no. If you are having the really skill sets are very strong, nobody can take the jobs. I'll come to that slides when I'm going to the lectures. How this is affecting the jobs and where to focus and what to focus. Because this is very in the market where we are having so much of technology and tech stacks are there. And this is data science nowadays, it's a very trending buzzword it is. Everybody say that I want to become the data science, I want to become the data scientist, and I want to become the AI expert. See, under me, 40 plus years of experience people are there working as a data science intern, not as a data scientist. Can you believe? Data scientist intern it is, not as a data scientist. It is intern. 44 years of experience he is having, but he is an intern. Because he don't know the domain knowledge. Again, the domain knowledge where it comes from? When you actually deal with the data. Again, the data comes from the platform. See, we are generating the data, everything is there. So, these are all fancy stuff. We don't have time for this. Just I skip this. I just focus on. These are all the things we are going to get from the book or the internet. And again, just nowadays, as I said, data is very important, not the time actually. So, in today's world or human era, everything is driven by the data. When you go to Amazon, when you go to Instagram, today just whatever things we are discussing here, go to home, after 2 days, you will get same type of conference details on your Instagram, Facebook or YouTube. This is personalized analysis. At the back end, we are doing the same. When you work for the healthcare US, we are having our own product. We are not concerned about which the clients are, what the clients are, but we need the accurate data. See, if I say, Honey Singh is going to have the bhajans. Do you believe? Because your brains are not designed like that to accept the data. If Honey Singh is actually delivering the bhajans, your brain is trained for that, right? But what is the type of singer he is? He is a rap singer. Already your brain is trained for that. Correct? If whatever the data you are going to give for the models and whatever before Watchara is explaining, see, all this depends on the data. Data is very crucial. What you are going to give the input, that you are going to get the models. And next to this, we are having the AI. Sorry, GenAI it is. It is totally different from the ML and data science. And it is not just writing the 4 or 5 lines of code. It is very different what you are learning, what you are doing in PO systems. Whatever the PO systems you are doing, it is not the industry-ready deployment code it is. Things are very different what we are learning and how we are implementing. So all these things. So again, many of the things in the course and all we see what's the big data, what's the data science, what the machine learning and all. Actually, this all are umbrella terms it is actually. If you want to become a data scientist, you should have some skill sets. If you want to become the big data developer or the data engineer, you should have some of the skill set. If you want to become the AI practitioner, you are having a different set of skills are there. But in real, these are all under, just like you can say these are umbrella terms, they are not detached. And in market, you are having different courses for that. They are charging 1.5 lakhs for big data, 2 lakhs for the ML, 2 lakhs for the deep learning. But in India, as per the trends, we don't have much of the projects related to the deep learnings. We have most of the things up to the machine learning is there. Because it costs more. In order to have the data, since we are dealt with the data for around daily, we used to receive 15 petabytes of data. We used to get the data, we need to do the analysis, and we have to, it's not like 1 day or 2 days we are going to get the outputs. We have to do the research for 6 to 7 months. The target is given for us. So that what the data we are receiving, it's not like we're directly going to feed this data to the models. We have to do a lot of circles on this data. Then only we are going to give this data to the models. Then only these models are accurate. Until and unless you are going to give the good data to the models, these are the dummy models, or you can say they are the off-track models. So this is not important. Since it is important, but not with this time. So especially when we're talking about the industry innovations, as we talk about the data, it is not like whatever the .csv files or .tsv files or .excel files you are getting to train the models. Actually, we get the data not in the proper format. And we can't go and tell to the clients or whatever the companies what they're generating the data. I want .csv file, .txt file so that I can train my models as per my requirements. They are not going to accept this. What they will say, whatever the data I have generated, you have to take this data, you have to train your models and give us the product back. So in this type of data, we are having 2 types of data sets. Already you know that, structured and unstructured. These are the common data, especially we are not going to deal with structured data. We are going to receive unstructured data, we are make it as a structured data, then we are going to train the models. And this is all circus we are doing in the big data stuffs. We are making the stage for the ML or the data science projects. And we are having the good skill set of the big data or data engineering and all. They are very, in the recent market, very less supply is there. Whatever the industry expects, there very less supply is there. Even for weekly, I used to take 4 to 5 interviews. They are very having the fancy terms in their resumes. They are having data science, deep learning, sampling, feature engineering, everything. When I ask what is Bayesian algorithm or some what it is, Euler's formula or some just simple things, they are not able to answer. When I say PCA, principal computer analysis, they don't know. Then what is this of data scientist? They used to say that I am a data scientist, and what's their expectations? 30 plus LPA. Seriously, it is the expectations, and the market is going to give that much of LPAs until and unless you don't have the technology for that, skill set for that. And this skill set again comes from your area of the domain. Domain is very important. Main conclusion of the discussion is only the data, the domain is very important. Domain knowledge. Until and unless you don't have the base for the understanding of the data, you are not going to deal with any of the ML or data science. And again, you are very good in mathematics, statistics and all. We had algebra, geometries, everything on the high school level. What we have learned the maths, we are going to apply small bits in the same ML models. We are not going to get the direct, take these 4 columns and train this model. Never this is going to happen. We have to do all the things. You are going to get one set of things. You have to take out you have to do sample engineering for that features you need to identify. Then you have to train your models. It's not easy stuff, and it is not going to be done in 6 months or 8 months. Minimum ML projects, depending on the requirements, minimum it will take around 1.5 years to 2 years in order to come for the production. So all these data related things. And again, what type of data we are dealing with? These are the different types of data. JSON, RC, ORC. These are all, I think you people might know all the formats already in your academics or whatever. But mainly we are not dealing with CSV files, we are dealing with the other things from 3 to 7. And the most trending file format what we are dealing in the industries, that is Parquet and the ORC. Why? Because they are having the features like that. They are capable of compression of your data and the flexibility with the schema evolutions. I know you might be aware of the schema evolutions and all. Yes or no? Schema evolutions. In database, you are going to have schemas for the tables. See, when you are going to push any of the data to tables, what we need to have? Firstly, we need to have the schema for that, right? Schema means what? You are creating the DDLs. You know, see, this DDLs and all in the industries, we are not going to write the code for this. This has to be automatically generated because you are getting 300, 400 of columns for the client data. If you keep on writing create data for column 1, column 2, it will take your ages. We are going to get retired from that there only. In order to achieve this, they are having some models, AI models. So this is a requirement. What I need, this has to be done automatic. In order to achieve this, I need to know about the data first. Why I am explaining all these things? Because when I started my career in the big data, I was not knowing that I may jump into the data science. I thought it is totally mathematics and statistics are there, but it is nothing like that. It's very, very simple things are there, but if you know the domain. And these are having its own set of, what you can say, characteristics are there. Based upon our requirements, we are going to select the type of the file formats. This is text, .txt file. Okay, you already know how this is done in the big data. It's in the blocks, we are going to store it and all. This is not needed, this is Hadoop architecture, this is all things. And again, whenever we talk about the data science, big data and all, you need to be very expert in the SQL. Not just create the statements or insertion into the statements, but you have to good in writing the procedural queries. Procedural queries means the scripts are also has to be automatically deployed. It is not just one statement. It is they are having around 800 lines of codes are there, and all these codes are just the SQL statements. Insert into upserts. You heard about upserts? Insert override. Insert override. We are doing the tables insert override, right? Yes or not? This is an upsert. If the data is not there, you are going to insert. If the data is there, you are going to update or you are going to ignore based on the requirements. So that things again in the big data or ML, even the data scientist or the ML practitioner, they need to have the SQL. And their SQL is what? They need to know the Hive. You know Hive, right? In the big data text stacks, you are having the Hive is there. This is again the very important things. We need to write the sum of the to get the data to train my models. I need to pull the data from somewhere. All the data are present through the Hive itself, Hive or Impala. Nothing else. You are not going to get data from the database or ORAS or the MongoDB and all. You are going to get from the big data or the underlying buckets or the cloud. In order to get that, you should be able to know the Hive. It's very important. Again, we are not going to deal with any of the internal tables. It is internal tables, you know, external tables and internal tables. I hope you know internal tables and external tables, right? Mostly the industry works on the external tables. We are not coupled with the data and tables. Even though because we are concerned about the data, not with the tables. On top of the data, we are having tables. We are not concerned about that. For us, the important is data. This is all the things, high data model. Okay. So, as I said, this AI, ML, data science and all, these are all umbrella terms. I know this is very familiar with you people. When ML word comes, everybody thinks of something. See, supervised learning, unsupervised learning, and reinforcement learning. Apart from this, there is lot of things has to do with ML. Not just three levels of learnings are there. There are a lot of things are there. And when it comes to AI or the data science and all, it is all again the mixture of AI, ML and DL. And particularly with this slide, just I try to convince means what exactly the machine learning, the things are involved. See, in order to do any of the data science project, we need to have some of the IDs, that is PyCharm or IntelliJ. Apart from that, no other or VS Code is there, but we are not familiar with that. Many of the industry level expertise, we are not going to write the code in the Jupyter notebooks. Or whatever the code you are writing in the Jupyter notebooks, that is not useful in the production level code. Because totally it is different versioning we are getting for the PySpark codes. Again, why PySpark codes? We are running the code in the cluster. Because we need to operate on the terabytes of data. If you are going to write just select star on some of the table, it's going to take 4 to 5 hours of data. When it comes to Spark, I think you know about the Spark also. Spark, is there right? Spark? No? Spark? Spark architecture? PySpark, Scala? Okay. See, because whenever the ML comes, we should know these technologies because you are going to work on this one. You are not going to write 4 lines of code on the Jupyter notebooks. Scala is very important to the analytics on the cluster level. Cluster level means whatever the WhatsApp you are sending the data. See, whenever it changes your mobile, you are going to get the backup of the data. It asks for one option, right? From that checkpoint, whether you want to recreate that, sorry, not recreate, you have to get back your data at what point it is snapshot the data. Are you getting or not? So what is that? You are having the backup of that point and you are re-getting the data. Where it is stored? How it is stored? It's not on the table, it's on the cluster level. In order to have this, if you are going to write some select star and all, it is not going to work out. You have to write the PySpark code for that. PySpark in the sense what? Spark plus Python. Not the Python, we need here Python for development like Python developer. No, it's totally different when it comes to big data or ML or AI things. It's totally different. And again the Scala, it's very important in the industries. We are having huge openings for the Scala. Weekly we do 30 of interviews, no candidate is selected for the Scala. It is going on. And again at the 4 PM today I am having interview for the Scala candidates. I don't know, we are searching for the good candidates, but we are not getting the candidates. So these all traditional ML. Okay. So coming to this slide, can anybody tell what is this?
Alien.
Fine. Who said that? Of course, it is alien. Correct. See, be confident. I'm not going to evaluate anybody is there. Just to have the interaction. Sorry. Yeah. This is an alien type of creature. It is species. It is. How you know this? How you know this? From the movies. See, from the movies you are generating the data or they are transferring some data to into brilliant minds and you are applying some models that you have already learned by looking at this picture, you are going to say that this is aliens. And when it comes to this, what is this? Sorry? No, it is not an AI model. It's a living being. Along with the technologies, what the world is going on, what the space research is going on, how the things are going on, it's very important to know. What is this? Can anybody tell? Can anybody tell what is this? It is the tardigrades. You can search later. This is the tardigrades and they are all the microscopic animals. They are called the water bears. You people don't know this. Even I also before this, it's already in last 3 years, it was in the trend actually. This tardigrades, where the Israel has sent these creatures into the space. It is having most of the important creatures. Why these only selected? In order to send the space. In order to leave the marks, saying for the future generation that the world is existed, the earth is there. Something to convey the message to the next generation or other aliens or other extraterrestrial planets. In order to convey this message, they have selected this one. You might have heard from Indian some songs are selected, from US some documents selected, they are sent to the space. That you heard? But this is all they are preserving our generation in order to realize that this generation is existed. How you are getting the fossils and all? That is vanished some million years of ago. Because of the proofs, in order to have that, they have selected tardigrades. These tardigrades are surviving at the extreme case of volcanoes, extreme case at the oceanic condition, without oxygen, without food, for 500 to 1000 millions of years. Just you can check over the internet. And these are sent to the space. And how you don't know, means see, when I ask this question, I am coming to our the main topic. You don't know this, correct? Because your brain is not trained for this. Now, if I show similar type of the things, what you can say easily you can answer. Now your brains are trained. This is a machine learning. Simple. And if I say 4 legs animals, 4-legged animals, what comes to your mind? See, different answers are there, right? This is not a specific to somebody saying cow, lion, cat, dog, right? Correct or not? This is GenAI. It mimics what you are already given. If I say the machine, you see, ChatGPT is what? This is GenAI. Cloud is what? This is GenAI. Gemini is what? Gemini. What it is? It is a GenAI. So whatever things you are going to give to the input, based on that similar lines, it is going to give you the outputs. It is, you are not going to train that. Already it is trained. You are just telling that, like this, I want this. Understood? This simple difference is a GenAI and MLs. And the work culture is also very different. On the pipeline, we are having GANs. In GenAI, we have the GINs. Some generators are there, some evaluators are there. This is happening on the flow. They are going to produce the data, somebody is there to evaluate the data, and again it will come to the feedback. Then you are going to get the ChatGPT outputs, because it has to match with your user inputs. Go to next. So, same it is, the typical supervised, unsupervised, reinforced, and how it is linked to big data, I have explained. Because big data, whatever the extracts is there, it is catalyst to the ML. Directly you don't get any of the ML stuff here. If you want to become the very good data scientist or AI practitioner and all, you should know the data domains. And again I am saying, exceptional cases are there. Out of 100, 1 or 2 are there. They are very good in ML or DL, writing the algorithms or writing the codes. Don't worry about the code nowadays. We are having the AI models for that. If you give the prompt correctly, it is going to generate the code for you. Not to worry about the code. Whatever the complexity of the code is there, not to worry about the code. In our companies, in previous companies, they are having the purchase version of ChatGPT. They are promoting to use the ChatGPT for us. But in some of the clients, we are not able to copy just one line of Stack Overflow into our code. Some agents are there, directly they are popping up from copying. Because everything is monitored. In some organization, they are promoting the AI. In some organization, they are developing the AI, but not with the publicly available resources. Go to next. Okay, so why I said only this finance and healthcare things is, mainly I have last from 8 to 9 years, I have worked on these 2 domains. See, in India, if you go to any of the hospitals, if you have a fever, the most very famous tablet is which one in India when you get the fever? Dolo, right? Dolo is a company, but what's the content it is? Paracetamol. See, doctor or whatever the pharmaceutical, he is not interested what temperature you are having. When you go and say I am having the fever, what will you give? Paracetamol, correct? When you are going to have the cold, what will you give? Sinarest at the max. Again, some cetirizine and paracetamol stuffs are involved in that, right? And when you go to any of the doctor and say cough, what will you give? Cough, sir. He is not going to check what's the level of the fever, what the level of the stupidity cold is there. He is just going to take this. He is going to give 10 tablets. Indian mentality, you are going to take 4 out of it. Correct? Because we say that, right? See, this is the Indian mentality, but this will not work in the US. When I am working for the US healthcare, this is not going to be the same. You are having the personalized drug is there, personalized medication is there. Personalized medication is there, we are maintaining all the dynamics of the patients, and we are never going to disclose that data because it's very confidential. If one data leaks, directly I will be put in the jail. We are not supposed to use the mobile in the office hours because of the privacy and the data breaching. Even our mobiles are covered with some stickers at the morning 10. When you go to the lunch, we are going to remove the stickers. Because everything is monitored and they are very concerned about the data, especially of the healthcare. So what we need to, we get the data from the hospitals, from the patients, what the doctor is going to write the prescription for that. Again, whatever the prescription written, it is automatically digitally converted and it is stored in some tables, and whatever the prescription doctor has given, it will directly not go to the medical shops or pharmaceutical shops. It will go to the hospital only. Like ATM machines are there in India, we are having the machines in America where the drug is pulled. Whatever the drug they have mentioned, they are going to pull that much of personal medication is there. And again, if you are going to tell the nurse, Indian mentality, doctor is given 10 tablets, if you are going to tell the nurse, just give me 4 tablets, what about the 6 tablets? On your transaction, they are mentioned, they are tagged as 10 tablets. And we are receiving the data for that, 10 transactions. And what is actually delivered to the patients? 4 tablets. We are having this transaction also, we are having the data. At the month end, we are writing some complex algorithms, just as the example it is. Similar such many of the case studies are there. These are one of the case study. We need to identify whether the nurse is outlier in the sense the suspect, the thief, or the patient itself. See, this type of the reports we are going to generate, and all these reports are somewhat around 300 to 400 lines of pages of reports is there. Whatever the US healthcare 2,800, some around 53. It's the data of 2004. I left that organization in 2024. At that time, this number of hospitals are there, or all around the US. They are tied up with this product, and they are going to send the reports. The very complex algorithms are there, machine learning models are there, and big data stuff. Everything is involved in the report, and we are going to identify them. Go to next. Okay, coming to this. In previous session also, when he is talking about the mammography, right? Mammography or any of the brain tumor. See, in academics, they are very much keen on doing the research on image processing. Try to have some innovations with the cloud or finance structures, healthcare. India is very huge market for the healthcare. Even whatever the US, we are working for the product. If I want to bring to this India, this is not possible. Even this is not allowed also. Because India is a very huge market, and healthcare, whatever we are there, 163 CR population is there. If these things are involved in India, see, we are writing all these products, we are writing ML models. For what purpose we are doing? We are doing for somebody else. They are all the developed nations, and ours is still it is a developing. We are not a developed countries. We are developing countries. This is the difference, because things are in the proper. Things are very much accurate, things are very much smooth, everything is monitored, everything is accountable. And similarly here, when you are going for the ML and all, data privacy and ethics, see, when you train the model, training the model sense, if I say instead of tardigrades, if I say that name as zebra, you learn the same things. If somebody else tomorrow, if somebody comes to you and asks, what is this picture? As you already gone through this in the sessions, what is this picture? What you are going to say? Zebra. See, this is wrongly trained models, and we need humans to interpret these results. That comes as a bias in ML models. The second point is the bias in ML models. We can't assure that ML is going to give you the exact results, or whatever the things it is going to give the models. It is not 100%. We need humans for that, in order to have the authenticity or accountability for that. And main thing is data privacy and ethics. See, again, in order to make the decisions in AI and ML, so why the world is switching to now GenAI things? You might have heard of GenAI things. Why the world is switching to GenAI things? See, you are not training the models. You are asking the model to prepare themselves, giving some outputs. In ML, what? You are giving input and output, right? In GenAIs, you are asking for the parallel model things, not the exact things. And there, one more is their last point, skill gap in workspace or the talent gap. See, until and unless, again the same, the circle comes there only, until and unless you don't know the domain knowledge, you are the worst ML developers. If you are the worst ML developers, including me also, the model is going to be worst, it is not going to predict the answers. And if it's the same thing, if the one student is there in your college, his attendance is very low, particularly for November and December. And that student is studying in college for last 4 years. And at the 4th year, the college decided to, this is one case study, and the management or the HOD or principal, they want to know what is the attendance or the percentage he is going to miss the 4th year colleges at the month of November and December. In order to get this, I need to have the patterns or guide students from the past data. If this past data is correct, the model is going to train correct and it is going to predict the correct results for it. If not, it is going to be the wrong answers. Go to next. Okay. So again, what is the key takeaways from this? In short time of it, not short time, I taken much more time only. So, in order to go for data scientist, my one suggestion is that because many of the academics faculties are there, when you are going for the students and all, just try to focus on not only writing just 4 lines of code, but they need to have some of the domain knowledge regarding to big data. These are all our sisters and brothers of the same mothers. Seriously, if you at least forecast something on these topics to one student, easily that can be placed. Nothing big deal. I am 25 plus package will be there. We are searching for the people or we are searching for the talents. Weekly we conduct 30 of the interviews, but from last 6 to 7 months we are not getting the proper candidates. And for me, I never got any of the resumes from Karnataka only. All are from Tamil Nadu and Kerala or else the Rajasthan or Jammu Kashmir. And sometimes here and there Maharashtra. I don't know whether they are. See, again, this is AI model is there in our company. It is trying to. It is already having my data from which state I belongs, where I have worked and all, work experience, everything. Based on that, that machine is going to sort out the profiles for me. Again, this is a use case. What the industry is trying to solve. Same such problems are there in the industries. What we are going to solve, not the POCs. What you people are doing. Whatever the POC you are doing, it has to be helpful for the society. Whatever things we do, see in WhatsApp and all, every 6 months, 8 months we are going to get an update. See, this update is one of the POC idea. When this POC comes to the enterprise level of deployments, then only you are going to get an update on your WhatsApp. That is, everything is checked. Okay, and the last thing, whatever the things you are going to start, all the things are going to at the small. Even the steam engines or the plastic research, everything has I started with the idea. Now they are the human, what you can say, essential of the humans. Next, what? Okay. Finally concluded the things. If you are having any questions related to whatever the tech stacks I have mentioned, if you ask questions in Java or cloud, means Azure and all, I am not going to answer because they are not my expertise. Whatever the things related to any of your questions, any of the doubts you are having, please free to ask. I am ready to answer.
So that drug design.
Sorry?
So in foreign countries,
okay,
you are mentioning that drug design will happen customized based on the prescriptions of.
Yeah, personalized medications. Correct.
So is that related to drug vending machines, like based on the prescription, the drug will be customized for a particular patient for a particular disease?
No, see, how the drugs are measured, even you are, I think when, I don't know whether you closely monitor the Dolo wrapper or not, Dolo 650. This 650 is the mg, right? Yes. Milligrams. Yes. This is the Dolo paracetamol content. Dolo 650 is not a brand, it is a brand name, but actually it is a paracetamol 650 mg. The same tablet is not given for the pediatrics, correct? It is not given. The mg or dose level or the dose content should be very less for the kids, the pediatrics. Just while going back to your home and all, whenever you are giving tablets or any of the medications to your kids, your family members and all, just try to always read the contents, not the brand. Progedex, Tuskegee, these are very common brands in India. But in America and US and all, they are not dealing with these companies, they are dealing with the contents. Go to ask in the medical shops and all, go and ask cetirizine, give me cetirizine tablet. If go and ask, and again cetirizine is given for the many of the disease, not disease, for the some allergic purpose it is going to give. When you are having sneezing, you are going to give the same cetirizine tablet. But here in India, everything is digestible because the soil is like that. But in America, coming to your question, they are very sensitive to these medications. And see, one cancer patient or whenever the fever, whatever, this is a small example I am telling. See, they are on the vending machines. Omnicell, Pixius, one more is the Akidos. Go and check on the internet. These are the vending machines available on the US. These are again the different vendors are there. This Omnicell, Pixius, one more is there, MedSelect. These are the vending machines, just like your ATM machine. They are having the drawers, set of drawers. They are having the composition. Based on that composition, the medications are pulled. Even though heavy customization is there, means personalized medication is there, they are going to take the time for that. Time in the sense 48 hours, not like that. And this personalized medication comes to the picture for the very rare disease like this. One of the mammogram is there, where it is the breast cancer or the brain tumors, where it is going to becoming large as the day increases. That time is all personal medication comes. And even in America, we have one dose is there, fentanyl. I think in news you saw that some American guys are falling on the streets and all, biting some drugs. It's in the news. See, the world is driven by whatever the AI/ML models are driven in the today's world. It is because of the requirements what we have, how they are addressing the human problems or the human life, how they are useful. Based on that only everything is driven. See, so, cars are there, driverless cars. See, if the driver is getting the sleep, this is one requirement, right? And somebody has solved it, and we are using it. Correct? And when, see, in your, before the cameras are invented, we don't have any of the image recognition for that. The hand gestures, SCI, right? Human computer interface, SCI, it is not there. Now all the mobiles are having SCI technology is there. This is the requirement. When you keep the selfies for all and all, you should, the requirement is what? It has to pick our picture without any the inputs. I am not going to touch the screen or I am not going to press any other button. So in order to solve this, what I need to have, when I show the palm or when I blink the eye or when I smile, it has to click the picture. This is one requirement and somebody has implemented that. Similarly, nowadays it's a trend, the image beautifications. This is again one of the trend it is. In order to look more smarter, more beautiful and all, we are going for some high-end mobiles. What are they having? They are having AI models in that. Apple intelligence, Samsung, in all, Android intelligence is there. See, this is intelligence in the what? They are having the data, what you people are doing, what you people are expecting. Based on that, you just think on that. We need, see, before in WhatsApp, we are not having the music. What we need to do for have the image and the music, what you are going to have? You are using third-party applications. For image, you are putting some songs and then you are uploading on the WhatsApp. And what is the problem here? You need to use the third-party applications. In order to use the third-party applications, you have to install it. Some privacy is compromised. It is going to click on yes for everything. What is asking your home papers there or your biodata? You are not concerned about the whatever is asked. You are just pressing on next. But in that, you are giving the consent. Whatever the context you are having, whatever the image-related information you are having in your mobile or in your cloud or any of the Gmails or your drives and all, you are giving the consent to use that. So now what you are having image and the music. This is one requirement. So I think it's very boring. So even if it's a case, when I am the audience, just I am looking at the time when this blah 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 will go and finish, so that I can have the good lunch and have this.
Snacks.
Okay, snacks also. So that I can go and home. Because today I think college is holiday. Exam is going. Okay. Fine. So any questions? First get down from the dais, right? See, there are a lot of things to discuss since 20-25 minutes. Just in order to say the text tracks only, that time will be very short. And I don't have any other fancy stuff of presentations here. Nothing like that. And my apologies on that. I think something I have drilled on your mind. Something, at least 1 or 2%, that is satisfaction for me. If that is also not, I am also helpless, you are also helpless. Fine, and thanks for the opportunities to inviting me here. And I don't know who is Dr. Mohana, madam.
Dr. Mounesh is Dr.
Okay, I think I have already, okay, sorry ma'am. And only I know this ma'am, and from today in the morning I know IEEE, right? Because these words are forgotten, and 2012 to 2016 I was there in the academics, same thing. IEEE chapter is there, CSC is there, IST is there, even lot of publications are done, everything. But from 2016 onwards, everything is stopped. We don't have time for that. Time in the sense, of course. But whatever the papers you are downloading, just try to make this as one innovation and try to contribute to the society. And thanks for again Gita ma'am, Mona madam, and Madhu, or one more Vinod. Yes, correct. And I express my sincere thanks to those people who has coordinated very smoothly, and thanks to entire Hassan, Malnad College of Engineering. I'm not coming from any outside. This is my place, Karnataka only. And with this, I conclude my words. Jai Hind, Jai Karnataka.
Thank you, sir. So it was truly informative because he stressed more on the industry needs and what exactly today's generation needs to focus on for their careers. So thanks a lot for that, sir. So we have snacks arranged. Soon after that, please join us for lunch at TAP office. A very light snack, and lunch is arranged at TAP office. And after the lunch, we have the offline session.
Light snack, heavy lunch at TAP. Light snack downstairs. Join for the lunch.
Please join us for the snacks and followed by lunch at training and placement office.
a professor and head in the Department of AIDS at Nautilus College of Engineering, Hassan. With over 23 years of rich teaching experience, she is deeply committed to nurturing future technologies and advancing academic excellence. She obtained her PhD from VTU Belagavi, where she focused her research on healthcare and data analytics. Her research thesis titled Development of Methodologies for Patterns Extraction from Healthcare Data for Liver Disease Detection has received appreciation from the jury members. Her contributions to research are evident through the publication of more than 20 papers in reputed journals and registration of an Australian patent in her name. She has actively contributed to the academic community as a reviewer and as a session chair in various conferences. She is known for her dedication to continuous learning. She regularly participates in industry training programs and has completed numerous certification courses offered by IITs, IUCEE and various other organizations. Her leadership extends to key academic and institutional roles, including the chairman of the Board of Examiners, the member of Board of Studies, chairman of Industry Advisory Board and Research Advisory Committee. She has also played vital roles as the NAC and NBA coordinator, convener of the Institution Innovation Cell, and as a member of several committees related to student welfare, anti-ragging and women's security. Dr. Vinutha has delivered several technical talks and contributed to student development programs across various engineering institutions. Beyond her professional commitments, she is passionate about community outreach, often visiting government schools to guide students on current trends and technologies and examination preparedness. At present, she plays a vital role at Nautilus College of Engineering, Hassan, as the convener of the Women's Cell, actively advocates for women empowerment and promotes gender equality. ISTE convener promoting technical excellence among students, nurturing a culture of technical excellence. Dr. Vinutha's multifaceted contributions, both in academia and societal engagement, reflect her unwavering dedication to education, innovation, and empowerment through knowledge. We are indeed very happy to have you here as the session chair for today's conference. I welcome Dr. Vinutha to this conference.
Thank you very much, Dr. Nandita ma'am, for such a warm introduction. At the outset, I would like to congratulate Dr. Geeta ma'am and her entire team for successfully organizing this conference, ICCTDC. Congratulations, ma'am. I always appreciate your dedication, determination, and discipline. And from the bottom of my heart, I thank Geeta ma'am, Dr. Nandita ma'am, and Mounesh for inviting me as a session chair for this occasion. And I wish all the participants all the very best. And I'm very eager to know the new technologies, and I'm very eager to know the ideas that is there in your young minds. All the very best. Thank you very much.
We will start with the first presentation. All the teams are here, right? Arundhati Priya, right?
Good afternoon, ma'am, and to everyone present here. My name is Vinita, and today me and my team are going to present our project on cardiovascular risk prediction system using retinal images. Before moving into the presentation, I would like to thank everyone for this opportunity that has been given to me and my team. So let's move into the presentation. So cardiovascular diseases are one of the highest mortality causes worldwide. Like 80% of the people normally die every day due to various cardiovascular diseases. So these diseases can actually be prevented if we got to know the risk, if we got to know the level of risk beforehand, so that all of this can be prevented. So the question comes, how can we know this? There are a lot of ways. Like you can go get an ECG done in your hospital, or you can go consult a doctor. But one of a very easy way that we have discovered is retina. Using the retinal images, we can predict the risk of heart attack. But now the question might arise that how is retina actually related to heart attack, or how does it actually help us predict the heart attack risk? So there was a study which shown that retina has similar blood vessels which are there in heart, so that the changes in the blood vessels can actually help us predict the risk of heart attack. So for that, we have taken retina as a means for predicting the risk of heart attack in our project. Next slide. So this is just a brief of the literature survey that we have done. We have actually, these are only the top 3 papers that we have taken. We have also done literature survey on many other papers. But this is just displayed to show the technologies that are used before, what is the differences from our model to the existing models that are already there. So we have the first paper, which is the systemic review and meta-analysis of applying deep learning in prediction of risk for CVD from the retinal images. They have used technology, deep learning and artificial neural networks. And the gap was that there were really high inconsistencies, because since the paper was released in 2023, research was not that much done in this area. So there were some inconsistencies in the studies. Then we have cardiovascular risk assessment using deep learning based retinal biomarker. In this, they have used retinal CVD deep learning biomarker to predict the risk of heart attack. Again, it limited in the ethnic diversity, and it affected the generalizability, in the sense they only concentrated on a particular group of people and not in a common. Then we have overview of deep learning based method for cardiovascular risk assessment with retinal images. Here they have used a CNN model with UNet and conception rate. But the problem here was they did not take a vast or a wide range of data set, but only took a limited amount of data set and trained their model based on that. So obviously, as we know, when the data set is less, or the training is less, so that the accuracy of the result is also a little bit less. So in our project, we have used CNN. Specifically in the CNN, we have used DenseNet one-to-one algorithm. So let's look at how our overview of how our project actually works. So we take the retinal images as the input, and these images are then divided into 2 parts, which is training data set and testing data set. Now both of these data sets are actually raw images, and those need to be pre-processed so that the model training can be done accurately, and it's easier for us to train the model. So both of the data set undergo the image pre-processing. Then the training data set undergoes model training, and the output of the model training is obviously we get the classification, in which it classifies the images into several risk states or stages, levels of risk. Then we have testing data set, which is again undergoes image pre-processing, and then it's actually fed as the testing for the trained model. Next slide, please. So these are the system requirements that we need for our project to run. the basic hardware requirements, Intel i5 and above. All of these are good if we have it, it's not mandatory, but Intel i5 or above, 8 GB or higher, because we need the model training to be done faster, because when we give a large number of epochs, it takes a lot of time for the model to be trained. So we need 8 GB and higher, and also GPU, if we have it, it's well and good. Then storage is 100 GB or more, because we have used about nearly to 1.5 to 2,000 images, so the data set is a lot, and to train all those things and to store all those things, storage is required. Then the software requirements are, we want a system which can work, which is fine with Windows, Linux or Mac. Then we have Python 3 for the machine learning, basic Python we need. Then the libraries we used are TensorFlow and Keras for the machine learning, main machine learning thing. And then we use OpenCV for the processing the image, and NumPy for, we have used, we get model loss and model accuracy graphs. To obtain the graphs, we are going to use NumPy. And then IDE is PyCharm or Jupyter Notebook, but it also works on VS Code. So these are the functional and non-functional requirements. Basic functional requirements is the system should be able to take the input images, and it should also be able to analyze the images using the trained model. And then it should classify the heart attack into the various categories that are there. Then we have the non-functional requirements, in which the system should be user-friendly and easy for the user to use. It shouldn't be too confusing for the user. And also the system must ensure that the privacy of the data, because since we are dealing with retinal images, people will be concerned about their privacy because it is sensitive data. So we must ensure the data privacy and the security. And also it should provide the predictions in an accurate manner. So let's look into the system design of our project. So the first input data we take is the retinal images. There are two types. One is the labeled data and the unlabeled data. The labeled data we are going to be later using it for the training of the model, while the unlabeled data we are going to be using for the testing of the model. So the labeled data undergoes image preprocessing. As I've told before, because preprocessed images are required for better accuracy of our model. So we are going to go with the image preprocessing, where it has various stages. The first stage is resizing of the images. Since we are using DenseNet 1-to-1, DenseNet 1-to-1 requires a specific size of the image, and also it should be in RGB form for the model to be able to train. So we will resize the image into 224 into 224 size, so that it's easier and for the model to be trained. Also the results will be accurate. So the first stage is resizing, where we will resize the images. Then it will go for normalization of the images. Normalization usually means that the pixel values will be in a various ranges. It won't be in a uniform range. So to maintain a uniform range of the pixel values, we'll apply normalization, so that all of the pixel values will be normalized in the value of 0 to 1, between the value of 0 to 1. Then we have data augmentation, in which the data that we have taken might be in different forms, like one might be straight, one might be tilted a little bit. So this data augmentation helps us to make sure that the image is straight, like it includes flipping, rotating, also cropping the data, so that we only have the proper retinal images. Then we have RGB conversion. As I have mentioned before, the DenseNet 1-to-1 requires RGB values. Like whatever data that we are going to give, image that we are going to give, should be in the RGB form. So the RGB conversion is important, because if the value or if the image is in black and white form, then it needs to be converted into RGB, so that model training is again easier. Then we have noise reduction, in which the unnecessary noise that are there in the images are reduced, so that the image data set that we have is clear for the training. Then we come into the model training, which again we have used CNN model, and it has, as we know, CNN is a convolutional neural network model, which has different layers for the training of the model. So we have input layer, convolutional layer, activation function, pooling layer, and fully connected layer. So the input layer takes the normal pre-processed image as the input, and then next it gives the output, the convolutional layer. Here, the convolutional layer in our project works in a way of, a convolutional layer is a layer and it has some inner layers in that, so that if an image is passed through a convolution layer, it works along with the activation function. So activation function and convolution layer works side by side. How does it actually work? So the convolutional layer actually will extract the important features from the images and passes it on to the activation function. The activation function then it identifies the important parts that are required and then passes it on to the next convolutional layer. So as I mentioned, there are different layers of the convolutional layer. So it runs in a similar manner, like first the convolution layer is going to run and then it's going to pass to the activation layer. From the activation layer again to the convolution layer and so on. So after that we have the pooling layer in which the dimensionality of the images will be reduced so that the model training and the accuracy will be increased. Then we have the fully connected layer which is going to take all the outputs and it's going to give us the classification that we need from our model, which is the classification will be done on the basis of the probability of the risk of heart attack. So if it's 90%, then it will be considered as proliferate. If it's 80%, it will be considered as severe, 70% moderate, and so on. Then this is the classification that's been done. Now comes the part about testing the data. So for the testing of the data, we are going to take the unlabeled data set. This unlabeled data set is unseen data, which can be randomly taken from anywhere. Like not randomly, but retinal images that can be taken. So then it again undergoes image pre-processing because the data needs to be clear. Then it is given to the model which is already trained. Then it's going to predict the level of risk of our heart attack. So this is basically how our system works. Next slide, please. So these are the project modules. The first part is data collection and preparation. We obviously are going to take the data, gather the retinal images. We have taken the data and organized it into different layers, like different folders, like no risk, mild, severe, proliferate risk, and etc. Then pre-processing module, which I've already explained, image pre-processing is done, where it resizes the images and then RGB conversion is all
go to the result part, I think.
Yeah. So this is the result part. So we have the model accuracy graph. This shows that over the epochs, the accuracy of the model has, the accuracy of our model has increased. And this is the model loss graph. Again, in the training model, how through the epochs the loss has been decreased. Next slide. So this is the confusion matrix. Confusion matrix is basically to give a comparison between the training model and the testing model, like how accurate the results are. So this middle line shows the similarity between the training and the testing model. This one. As we can see, there is a little bit of confusion between the moderate and the severe proliferate, because since the blood vessels are very similar to each other, so it's a little bit difficult, but we have tested the model and it's working properly. So this is how the result comes. We actually do have a front page which in which the user can log in and log in into his account to access his data and everything. But this is the actual prediction result that we did, that the predicted risk level is moderate or severe or mild or not at risk or something. So basically our project utilized AI models like CNN to predict the risk of heart attack, which in a long run can help to know better about our health so that we can prevent it. So the further enhancement of our, obviously we can use larger data set. There's no limit to the data set that we can use. So larger data set can be used, and also to add more health data. This our project is actually just a research level project. So we do plan on making some improvements for it, like adding more health data, or maybe if they are at severe or proliferate risk, providing them some other tips or some other ways from which they can make sure to overcome the risk, and also to improve the AI model that they have used. These are other references.
So, like, what is the source of data you have collected? From where have you collected the data?
We got it from Kaggle, ma'am. Half of the data set we got it from Kaggle, and the other half, the untrained one, we got it from Google. Like, we wanted the one which are not trained for the model, so we got it from Google.
Number of records that is being considered here?
Images.
Number of images, yeah.
For total images was somewhere near 2000, ma'am, and then 64% we have used for training, then remaining the percent we have used for testing and validation.
You have gone for a multi-class classification. How were you able to get images of different classes? Like if it is only the classes of retinal images which you could classify as risky or non-risky, that would have been fine. But here you have gone for multi-class, like moderate, severe, and so on. So for each such class of data, you need more number of images. Were you able to get them?
Yeah.
How many?
In the Google Eye, Google is only providing there's a Google Eye website. Google Eye website is there. There we can get all the cases of data. Means someone is having almost proliferate cases. All the different set of data set is there. So totally we have taken almost 13 to 14 GB something data was there. It was in the whole bundle, and Kaggle and Google Eye, we have mixed both because we want more the data to increase the accuracy of our model.
It is in thousands, more than 10,000 images?
No, not more than 10,000. Thousands in thousands only. So that's the maximum image means we have got actually, because as per medical research, they haven't give that data set.
They don't give the permission.
So
Also, how about the percentage of people who have done research in this area, like relating retinal images to cardiovascular diseases? How validated is it?
According to research, our eye is the overall means as we see it is connected to brain and heart and palm. So almost research is done on basically brain or heart or palm. So compared to eye, very almost 10% we can see the research paper. We hardly get minimum of 15 to 20 papers we got.
For the literature survey, we only got
What could be the reason? What could be the reason?
I think accuracy may decrease if we consider.
Definitely.
But there is a chance that according to scientifically proved only we can
But when you are dealing with healthcare or health of an individual, there must be minimum margin for error, right?
And also, since it's eye, ma'am, it can't be the only, like CVD can't be the only reason. There might be some other risk factors also. So considering that, people don't know.
And you told about data augmentation. Can you say what is it used for? Data augmentation.
Ma'am, we want the model, whatever the data that we have got, it might be in a, like, if I am training the model using my images, so the image that I got from WhatsApp or somewhere else, it might be not in the straight position or portrait or landscape, it might be rotated or flipped or something like that, mirror image might be there. So to make sure that all the images are uniform, we use data augmentation to make sure that the size is proper and the dimensionality, like it should be straight and for that.
Almost it all matches with the training data set so that it can increase accuracy. See, if we give as morning session sir has told, we don't know in which form or how the data will be. So that's why we use.
That is not the reason why you use data augmentation. Your model should be able to recognize all your images in whatever way it is, in whatever orientation it is. It should be able to do that. To allow your model to do that, you are doing augmentation. Data augmentation is just taking an image and obtaining its mirrored images in different ways. Okay, you
So
don't
it's
do
not
it for
actually
correction.
changing.
You change it so that your model will be able to recognize it in any form. What is the kind of activation function you have used for your model? CNN model? ReLU. Why not sigmoid?
the images, which activation function is better for image?
To say that ReLU is better, you should have tried with some other activation functions also. Did you try? You tried one and concluded that is better.
It's not like that.
Then
we did some research and it said that ReLU was, good or something like that. So we.
What is the accuracy you got?
92%.
How do you ensure that there is no overfitting?
For that, we have used something called as global.
Okay. Who is Arundhati and Priya here?
That's our guide.
Okay. You are from?
Silent.
Next thing, development of AI-powered model for oral cancer detection is here. Ashimi. Only you?
A device, maybe a hardware device. Why we are building this device for detecting the oral cancer? So as we know, the oral cancer is a very it's a vital cancer which will be detected in the very late stages. So because of this late diagnosis, many patients die because of this reason. And the other reason why they die because of oral cancer is because even though there are many hi-fi devices to detect the oral cancer, they are not affordable or they are not available at cost.
Yeah, you can.
So to address all these issues, we are building this device called AI detection for oral cancer. So these are my teammates, which are they are not present right now. So I have worked on this software domain. In the software, we are particularly using the AI technologies. In the AI domain, we are dealing with images of oral cancer people. So basically, we will get the images of the patient's lesions of their mouth. So for this thing, we have collected the images to train the model. So as we conducted the literature survey, we did a extensive literature survey. We studied around 20 papers, and we, as a software part, we studied which are the papers they are only focusing on images and how can we get the best results from the images, which are the models that can be used. So there we understood that the CNN models in the domain of AI, CNN models they are extensively used for images. So as I mentioned here, they are using CNN models for image processing, and in particularly CNN models, there are many CNN models for image processing, that is VGG, ResNet, DenseNet. So initially in the first phase, that is the initial development phase, we decided that we'll experiment with 3 models, that is VGG, ResNet, and DenseNet. So after that, in the initial preprocessing, we got more accuracy for DenseNet, especially DenseNet 201. So we thought of going into this particular DenseNet model. And coming about the data set. So we initially in the development we got two classes of images, that is cancerous and non-cancerous images. We obtained these two classes from the Capgemini dataset itself. So initially the size of the dataset was 500 cancerous images and 450 non-cancerous images. Since the model we have chosen, that is DenseNet, is very large, so if we are training that big model on this small dataset, again there will be a problems of overfitting. So hence we thought of doing the data augmentation for it. And later stage we came upon a use case. That particular use case is like whether if anybody is capturing the images of non-oral images, maybe random images like a hall or any nature scene, then the model has to particularly tell that this is not an oral image. So you have to provide a proper oral image. For this use case, we came upon another class called random class and trained the model on this random class also. So right now we have trained the model on three classes, that is cancerous, non-cancerous and random class. As a part of pre-processing of the dataset, we have performed augmentation of the dataset. So in this augmentation part, we have applied many transformations on this dataset. That is, we have used rotation, width shift, height shift, CR transformation, zoom, horizontal flip and fill mode. So these are the augmentation we have performed on the dataset. So after augmentation, we have the dataset size has been increased. So we have after augmentation we got around 2,500 cancerous images and 2,250 non-cancerous images, and we got around 2,822 random images. And before augmenting, we had to split the data. We have split the data into train, test and validation images. So this is how we have divided it. That is 0.7% for the training purpose, 0.15 for the validation and 0.15 for the testing images we have kept it. So these are the images, and the total size of the dataset will come around 1.1 GB. So
what is the size of each image?
Ma'am, it was varying, ma'am. It was in KBs only. It was some KBs, but the resolution was around 153 to 164. But again, we had to normalize it to the standard DenseNet model's resolution, that is 224 into 224. So we have chosen this DenseNet model. As we went through, it was giving more accuracy for this thing. That it has the architecture of DenseNet. It gives more strengthens the feature propagation, and it as I said, it achieved better accuracy compared to ResNet and VGG, and it encourages feature use, and compared to DenseNet, compared to VGG and ResNet, the number of trainable parameters in the DenseNet were less. So this is the architecture of the DenseNet 201 we have been using. Inside the convolutional neural network, how the DenseNet differs is, it will have this dense block and the transition blocks. So this is how it differs from the other CNN models. So this dense block will again have these many layers, wherein the input of all the layers will be going to each and every layer. So that each and every layer will extract the features from every layer, not just from the previous layer. So this is how DenseNet differs from other CNN models like VGG or ResNet. So this transition layers, it is particularly used for downsampling of the images. So in our DenseNet model, what we use, these are 19 million, the total parameters which was 19 million, and among that 19 million parameters, 11 lakh was the trainable parameters, and the non-trainable was around 80 million. So the total model size after training on our dataset, it came around 84.0 MB. So this is the output what we achieved. So we got around 0.916 accuracy, and apart from accuracy, we have also calculated other metrics, that is AUC, loss, precision and recall. So as you can see that we have got less loss, and even the precision score is good. And after building this model, for the further integration, we have built user interface. So what we have done is that we have integrated this DenseNet model with a Flask backend application, and we have built a basic UI like this, so that the user or anybody, doctor, anybody using this website can log in or sign up, and they can just, this is a sign up page we have created, and login thing. And here for this thing we have used the basic HTML, CSS and JavaScript. To construct for the front end we have used this thing, and to integrate the model with the back end we have used Flask. So there is a particular section in the home page where the user can upload his image to the model, and he can get his prediction results like this. So the model tells what is the basically gives the confidence intervals, how to which particular class it may belong to. So in this particular image we can see that the images of particularly cancerous images. So like that we have given normal images also. So here this tells that no cancer detected. And here if we give any other random images, maybe like, as I said, any random images like mine or in this halls, anything, it has to tell that not in oral cavity images. And this gives the message like, this appears to be a non-oral cavity image. Please upload an image of oral cancer detection. So this is the software part we have implemented. And coming to the hardware, this is the overall view how the hardware will look like. This is basically a robotic arm mounted on an orange pipe chip, and it has, at the tip of it, it will have a camera through which the doctor will capture an image, and that image will go to the model which will be deployed on this orange pipe chip. Yeah, these are the different views of the model, and it will, at the basement have a screen view where that website which I mentioned, where view will be deployed here, and we can see whether the patient has oral cancer or what it is. So these are the different components we'll be using, that is orange pipe, ESP32, SMPS, and this is the motor driver we'll be using. And as I said, at the tip it will have a PIN HD camera, and this is a display, and these are the actuators we'll be using. Yeah, that's it.
Before I ask any question, I would like to bring to your notice that Dr. Nandita ma'am, her area of expertise is this one.
Yeah, ma'am, we also took her guidance also.
And she has published data set in Mendeley database.
Yeah.
She couldn't use that, huh?
Ma'am, as your student said, we refer that also. All the images are completely combined. And then only we got...
So both from Kaggle as well as Mendeley.
Some of like Anusha or Amrita, some of your student only she sent.
My question is whether that non-oral images, is it required really?
Non-oral...
It's an overhead, I think, no?
Yeah, ma'am, like we have to still work on it. We have to just...
Because whatever your camera is, you are just trying to develop a hardware for this thing, where the camera will capture the images of the oral cavity. So there is no point like it is going to capture other type of images.
Yeah.
It is only oral cavity images. So is it really required? The
No,
third,
ma'am, not necessarily, because in the initial stages when we came across that use case, so we thought of like that, and now while deploying we'll remove that class, we'll retrain the model and do it for 2 classes also.
Simply you are overburdening your AI model, I think.
We'll do it precisely.
You told early detection or early prediction, right? Can you please suffice on that, how early it is being detected?
Ma'am, like when the patient comes, like for detection, this model or like it uses computer vision to know the early lesions, like early signs. So the model will be trained like that. We can still go like benign and malignant. So any benign cases like early lesions or any small lesions which shows the potential of the oral cancer, it can be trained on that and said that it is the early signs of this oral cancer.
Now for that you need to have images of early oral cancers.
Yeah.
You need to have a data set wherein you have those kind of images, so that even with those being tested, it will be able to classify them as early oral cancerous images.
But the images what you have here, it's not early.
They are of late cancer
They are combined right now. It has both like benign and malignant.
No, have you classified them as early cancerous images and late stage cancerous images?
No,
better,
you
I
told
think.
early, no, you should have included.
For early oral cancer to be detected, you should have early cancerous lesions. Like even if it is a benign lesion, it appears to be cancerous, but then it should be able to distinguish between them. There are some kind of ulcers which are not cancerous. So
polyps also.
Polyps, yeah, or simply cuts. They are also benign lesions.
Benign lesions. It shows like it may lead to oral cancer, but it is in a very benign stage.
So it's quite difficult, I think, because the patients, they only turn up when it goes into a later stage. So how do you get those images early?
Ma'am, early we have to, apart from oncologists, we have to also go to dentists. We have to also go to normal general physicians, collect the normal images also. Like if a patient comes with a case of ulcer or a small polyp, we can collect that images. Apart from
The
dentists,
routine oral screening.
yeah.
You should be able
And
to.
also we can consult dentists because patients regularly go to them. So we can consult them to know any early screenings.
Next is comparing the average delay and power consumption of decoders.
Coming to the motivation of this project is to identify the most efficient logic style of the decoder. Main objectives of this project is to design and compare 1:2 decoder using various logic style of the decoder in schematic level and layout level. I referred 10 paper for this project. One of the paper is most of the paper is design transmission gate logic level using 180 nanometer FinFET technology and 90 nanometer technology. And power consumption of the paper is almost 66% of the reduction in power delay and 15% is reduction in power consumption. And most of the paper we have designed using NAND gate and NOR gate for the design DDL and TGL logic. Coming to the methodology, this decoder is 1:2 decoder. A0 is the input and D1 is the output. Here A0 is to be 0, D0 should be active. Where the A0 is 1, D1 should be active. Using static CMOS in cadence in 45 nanometer technology, in inverter, this taken input is for designing 1:2 decoder in static CMOS, we need AND gate, NAND gate and inverter. For the inverter, when the input is 0, when the PMOS is inactive and NMOS is inactive, at the time channel is creation between the ground to output. That time when the input is 1, output is 0. When the input is given to the 1 in the gate terminal of the PMOS transistor and NMOS transistor, and the PMOS is active, at the time channel creation between the mediator to output. When the input is 1, output is 0. Coming to the NAND gate, we need AB is the input and Y is the output. We need
transistor and 2 NMOS transistor. For this, for the AND gate, when the any in of the input is 0, output is always 1. For the NAND gate, if the combination is AD is 0 0, output is always 1. 0 1 combination also output Y is 1. For 1 1 combination, output is 0 in the NAND gate. For the AND gate schematic level, we need inverter and NAND gate. Previous slide I designed NAND gate and inverter that will be used in the 2 input of the AND gate schematic level. Here we use AB is the input and output is the Y. In the AND gate of the schematic level, when the any one of the input is 0, output is always 0 in the AND gate. It is coming to the 1:2 decoder in the schematic level. We need inverter and 2 input of the AND gate. When the A is the input line, B is the select line. When the A is 0, output is D0 is active. A is 1, D1 will be active in the B is select line. This is the layout of the static CMOS where design the background here we design 1:2 decoder in the schematic level. In the schematic level only functional view of the circuit, like every functional view. In the layout level you have to identify the physical arrangement in the chip level. In the next slide. Here we can see the physical arrangement of the layout where we before slide I have designed a schematic level of the decoder. Here first is the blue line is the metal 1 layer. That is red layer is the metal 2 layer in the layout level. Polysilicon layer is the metal 5. Here we design inverter, AND gate and 2 input AND gate and 1 inverter. Design in the schematic level. This is the pass transistor where design. You have to pass the logic level to the input. Where all designed pass transistor, sugar MOS and static CMOS. We need AND gate here, 1 PMOS we need and 3 NMOS need for the AND gate for the pass transistor logic level. Where the A is the input 1, PMOS should be active at the time, output should be 1. When the 0, both the input is 0, at the time NMOS level is 0, channel creation in the ground to output we have 0 in the AND gate. This is the 1:2 decoder in the layout level of the pass transistor. Schematic level. We are using inverter and AND gate here also. In the decoder, where we have previous year slide we have designed on static CMOS. Here we design pass transistor. This is the layout of the pass transistor of the 1:2 decoder. I have designed 1:2 decoder in different way. These are all different way to design. Here in sugar NMOS NAND gate we design 1 PMOS we need and 2 NMOS we can need in the NAND gate.
So you mean to say these are the different ways of designing the
decoder and compare the delay and power in the.
I think it's better we go to the comparatives.
This is the result level. In the previous I explained where the input is 0 in the inverter case, output is 1. This is the input. Red line and green is the output. When the input is 0, output is always 1. When the input given to the one, output is 0 in the inverter. In the NAND gate schematic level, AB is the input and Y is the output. Any one of the input is 0. Like 0-0 combination, output is always 1. For 0-1 combination, output is 1. 1-0 combination, output is 1. Always 1-1 combination, always output is 0 in the NAND gate. For the the AND gate, any one of the input is 0, output is always 0 in the AND gate. In 1:2 decoder, A is the input line, B is the select lines for the enable key. D0 is the output. A is 1, D0 will be active in the select line. This is calculate the delay and power consumption of the decoder. Compared to all past transistor CMOS, static CMOS is less delay compared to past transistor CMOS. Static CMOS require 2 PMOS and 2 NMOS. Delay is 39.131 nanoseconds. Compared to the past transistor, 154 nanoseconds we take the delay from input to output, we take the delay. Coming to the schematic level, we take 39% nanosecond we need for the schematic level. For the layout level, 49.5467 nanosecond we need for the layout level for the static CMOS. This is the most efficient logic style is the static CMOS. We need less delay and very less power consumption for the decoder. Static CMOS is the most efficient logic style compared to other CMOS and the past transistor logic style.
Where do you find practical applications of these inverters or in comparison of the delays of different kind of this thing? What are their applications?
In the memory addressing we need this one. Compared to all design states, static CMOS we need less delay and less power. Compared to the static CMOS, CMOS and past transistor. Compared to those things, I refer static CMOS is the most efficient for the less transistor we need to compare to other style of it.
You mentioned pseudo NMOS. No. What is its advantage compared to the real NMOS? How does it make a difference?
Yeah, real pseudo NMOS is only one PMOS we need. Large number of NMOS needed. Compared to the NMOS, we need both PMOS and NMOS will equal. For pseudo NMOS, only one PMOS we need.
It will function as both NMOS and PMOS. That is why it is called pseudo NMOS.
So here your conclusion is based on only the delay factor.
Yeah.
Can you consider any other factors to say which is better or which is
compared to the other static CMOS is the better.
That's what the only parameter that you are using is delay.
Delay and power. Consumption for both.
But the conclusion what you have written is only on delay.
Delay and power always.
No. Go to the conclusion.
Apart from these two parameters, are there any other parameters which distinguish decoders from one another? Like which one is better decoder? Whichever has a lesser delay, whichever has a lesser power consumption, that is considered to be a good decoder. Rather than these two parameters, are there any others which you have studied in the literature survey?
Area is
Area. Area of what?
for the area of in the circuit what was the power consumption delay I calculated. In the area you also calculate the what is the need for the transistor PMOS and NMOS, what is the
space occupied, you are saying. What is the meaning of area? Area of what? Fine. Go ahead. Rashmi, Zamir, Gautam.
I request anytime team to come on the dais. Ashwini Kutsu. ಬಿಡಿ ನೀವೇ ಕಲೆಕ್ಟ್ ಅಶ್ವಿನಿ ಕೊಡು ಫಸ್ಟ್ ರಿಕ್ವೆಸ್ಟ್ ಅಶ್ವಿನಿ ಟು ಕಮ್ ಆನ್ ದ ಡೈಸ್.
ತೆಗೀರಿ ಫ್ರೇಮಲ್ಲಿ ಆನ್ ಮಾಡ್ಕೊಳ್ಳಿ. ನಾನೇ ತಗೋಣ ಬ್ಯಾನರ್ ಲೈವಲ್ಲಿ ಮೇಡಮ್ ಒಂದು ಸೆಕೆಂಡ್ ಇದೆ ತೆಗೀರಿ ಹಂಗೆ. ಝೂಮಾಗಿ ಇನ್ನೂ ಝೂಮಾಗಿ.
ನಾವು ಇಲ್ಲಿ ನೋಡಿ
ಇಬ್ರಿಗೂ ಒಂದೇ ಕಡೆ ಟೀಮು ಲೈಟ್ ಆನ್ ಮಾಡೋದು ತೆಗಿತಾರೋ ಚೂ ಮುಂದೆ ಬಂದು ಸ್ವಲ್ಪ ಆಯ್ತು ಓಕೆ ಮುಂದೆ ಬಾ ಅಂಜರ ಆಯಿತು ಥ್ಯಾಂಕ್ ಯು
ಥ್ಯಾಂಕ್ ಯು.
Our project is a multi-functional borewell rescue robot for enhanced child safety. The contents are a problem statement, introduction, case study, literature study, aim and objective, block diagram and circuit diagram. Problem statement. Nowadays the borewell incidents are happening more in India especially. From the year 2018 to 2021, around 348 cases have been registered. Around 288 cases are death. The persons, victims who trapped inside the borewells are right now they are dead. And even as we said, our project is multi-functional borewell rescue robot for enhanced child safety. The robot, what it do is, it approaches the victim and handles the victim body and take the children out of the borewell. These are the case studies. In this, if you see the sixth one, Chaitan. This is an incident happened in December 23rd, 2024 in Rajasthan. The children, the Chaitan was trapped inside around a 70-foot borewell depth. The rescue operation was conducted around 10 days. The rescue person's NDRF team took around 10 days to take the victim outside from the borewell. So, and also in 2025, in the same state Rajasthan, there is another incident. The victim fall into 150 foot inside the borewell. The to recover the body, dead body, not alive, to recover the dead body, they took around 14 hours to 14 hours of the operation. These are the case studies. These are the real rescue operations conducted by NDRF in the fire departments. Some papers we took for reference for our project. These are the different types of papers we took for the reference. These are the existing models right now in the India itself, but these models are not able to rescue the victims. Till now, any robot not able to rescue the victim. So we took it as a challenge. The operations were conducted in India around, they took around 10 days, 7 days, 8 days time, around 170 hours like that. So our aim is we have to conduct the operation in 1 hour itself. Within 1 hour, we have to rescue the baby out of the borewell. So these are literature survey we took as a reference. The mistake which were done by previous existing projects, we corrected it according to the NDRF team suggestions. We took suggestions from them also. The aim of our project is to develop a technology advanced robot especially designed for safe and efficient rescue of the children trapped inside borewell. The object is multifunctional borewell rescue robot. Project is to develop a robotic system specially designed to safely and efficiently extract children trapped inside the borewell. We are not only taking the victim outside from the borewell, will rescuing the victim. Maybe there are chances the borewell surrounding is not a safe while rescuing. So we are designing a cage-like system. We took inspiration from army deployment structures. If we saw those structures, the compatible size they are, but when we deployed it, the size of the those systems will be bigger in size. So we are using those type of systems also. As we know, the borewells is not only very narrow size inside the earth. So to minimize the risk of the both children and rescue persons, if we saw previous operations, the NDRF team maybe one person will dig the hole and go inside to rescue the baby. So where there is chances of the risk of the rescue person and children who trapped inside the borewell are higher. So why should we have to send a human to rescue the other human? We can build a robot to rescue the person. So this is our objective. These are the components we are using to develop a robot. The Cytron Smart Drive and Hobby Rotor Pro 40 amps drone ESC and linear actuators and Cytron 60, Skyrod H16 and Runmo electric winch. Here the Skyrod H16 remote controller, which we are using because it has a long range of radio communication. It can transmit the signal around 15 kilometers away. So in our literature survey, almost the victims are trapped inside the borewell are 100 feet above only, not below 100 feet. So this receiver and controller we are using, so it has a much higher range in atmosphere. But when the radio signals were going inside the borewell, maybe there are chances signal will be destroyed due to moisture and metal content. So we conducted some tests. There we sent around 100 meters depth. So the sending and the receiving signals were properly working. Here we are using PAR sensor to detect whether the baby is alive or not for that reason. And to hold the victim, we are using a soft gripper mechanism which is controlled by the airflow. It is originally developed by the NASA. And this is the case system we are designing right now. This one. extract to the according to the borewell design. When the victim is came inside by using tactical sensors, it controls to compress, but the pressure of the compression should not affect the baby. So that's why we are using tactical sensor. This is a prototype outer structure for our robot. This is a block diagram. The entire operation should be live streamed in the surface who operate in the robot. So we are using 4K camera. To control the soft grippers, we are using solenoid valves. And also this is the entire system was developed in DC, operated by DC supply, because the rescue will be not only, maybe when the rescue was going on, the power supply problem will be there. In rural areas, the power problem is more. So we are designing entire system in DC. So when the rescue operation was going on, the fire vehicles and NDRF department and army vehicles, some other ambulance are there. So we are designing something like we took the power from the vehicles. So vehicles from around 24 volt DC supply. So we don't need to face any power problems. This is the circuit diagram. Currently we are working on it, and also we are going for patent also. The outcome of the project is simple, the safe rescuing the victim without any harm.
The prototype is ready?
Around 50% we completed. We are waiting for the transfer amount to be.
What is the maximum depth it can reach to any vision?
Ma'am, right now we are, our robot, it will go around 15 meters only, ma'am, because we need to minimize the fund usage. We have limited funds. So it can go around 15 meters depth only, ma'am. But if it has to go out more, we can just change the cable size. That's it, cable and wire size. Same robot and same controllers can be used to around 700 feet depth.
How is it going to pick that chain up?
Ma'am, by using soft grippers.
Soft
grippers. Ma'am, it is developed by NASA. It can hold the weight of its. If the material was we use it to develop design a soft gripper of 100 grams, it can hold 1,000 times of its weight. So right now we are practically testing it, ma'am. But we are getting good result. But we have also contacted some NDRF department teams who have worked really in this operations. So we are also getting feedback from them. So we are updating the robot day by day from their suggestions.
No, is any kind of image processing system being used here which will capture in what way the child has fallen there, or what is the orientation in which the child is present there?
For that we are using a 4K action camera, ma'am. Because the name indicates a multifunctional borewell rescue robot. If we developed a robot which have to use some other operations also. First we went for a drone camera like Skyroid C13 something. But when we think the camera only used for this project only. So we think we can shift to action camera, which is a waterproof. And if the NDRF teams conducted some other rescue operations, same camera they can use to other operations also. It is a multi-usable. So we just shifted to this one action camera, 4K action camera.
Okay, fine. You are using that camera to capture the image. Later, what will you do?
Ma'am, the image will be fitted to the operator controller, ma'am.
So accordingly, you will operate the gripper.
The rescue.
Soft gripper has to be operated externally.
No, ma'am. When the robot will go around 10 centimeter to the victim, then the linear actuators, if you saw the reason we are mentioning linear actuators, the linear actuators will be go near to the victim, and the size will be automatically adjusted by the operator, ma'am. We are not going for automation. Entire operation will be manually right now. So the grippers should be operated by the operator itself only. Here we are not only using one display, ma'am. If you saw the Skyroad, there is a display in that, inbuilt display. The operator should be monitored by that display only. But the thing is, maybe sometimes operators also do some mistakes. So we are using external another display which is connected to the Skyroad controller. That display for the other rescue persons. They have to monitor if he doesn't commit any mistakes while rescuing. So we are using here two displays, ma'am.
What do you consider as the risk factors involved here? With the implementation of your robot, what do you think would be the risk factors?
Ma'am, right now in India, around 75% of the rescue operations are failure. If our project, by using our project, the risk factor will be 100% we can give the output, ma'am. Because we are not only implementing our ideas, we are also taking from the rescue persons who faced the real problems there. So the chances of the success of the project were increased, ma'am. Compared to starting our ideas, right now we are completely different from them. We are updating from every moment, every feedback. So I think if the project was completed, there is no chance of failure.
So have you visited personally any fields, any bore wells, or is that theoretically you have done the literature survey?
In my home, in my home there is a bore well. Right now it's supplying water for the paddy field. So I conducted a test there, ma'am, because we need a permission from the government to conduct some tests. So we contacted some India team also, but they are suggesting in call only. Once the model completed, they want to visit Mumbai, Delhi for their headquarters, ma'am, conducting other tests and updating.
And when you displayed the existing systems,
yes,
you told that it is not successful. Could you please tell me the reasons why it is not successful?
Ma'am, there are two.
Can you please go to that slide? This. Is it used or is it at implementation level?
Ma'am, there are two robots only using right now. Only one robot rescued only one time, ma'am. In Gujarat, the accident where happened. These robots are not using currently because they don't consider practical problems which they have to face. They developed in lab, but practically a lot of different problems they have to face. If you say there is no oxygen supply, in this the metal rods are holding the victim like this. If we saw the literature survey, the victim will be struck in different different ways. There we cannot use this system, ma'am. And in this design, they are using simply robotic hand. But when the victim was holded by this, the victim will be stripped away from the robot.
Have you personally seen all these devices?
Ma'am, they uploaded some videos and everything. I watched everything completely for literature review. But by using this robot, the success rate is zero.
My personal suggestion is, better have a look at all this in person. Then you will get the clear picture of what you are supposed to do.
Yeah. But in video also they completely explain, ma'am. But once the model completed, we want to take the model to them also because we need a suggestions. It is not a personal project, ma'am. End of the day, we want to save the human. So our thing is we need lots of suggestions from the other persons also. Maybe right now, as you give suggestion, we can visit there and get some suggestions. Right now we can't do it, but once the model was successful, completed, we will definitely visit them.
What inspired you to take this topic?
Simple. In 2016, there is an incident that happened in Chavan, in Siachen glaciers. Landslide who trapped inside the glaciers. They took around 7 to 10 days to rescue the operation to find the victim. So we took it from there.
What is the motivation for you to take this?
And also not only that, if we there is a failure rate is more. Around 75% of the operations were failure. Only remaining 25% operations were successful because of they are using manually, ma'am. But not using by the robots. Manually they are taking out. So the risk factor is more. As an engineer, we took this as a challenge. So we try. Why can't we should try? We are just trying.
Very good. You have taken a wonderful topic, and I wish you all the best. And I would like to see you succeed in this because it will be useful for mankind.
What is the approximate cost of developing this?
Right now, the cost is increasing, ma'am, because we want to give the best.
How much? How much? No, how
Right
much
now,
you have already spent?
We have spent 1.5 lakh. Still 1.5 lakh has not been released. Again, we have
No, whatever it is, what is the total approximate cost of development, the final product?
I don't know, ma'am, because
Don't know.
actually we started with 50K, but right now we are using 3K funding, but still we need a lot of funds. Because the updation, ma'am, as I told before, when we start, we are thinking about the ideas. Our ideas is completely different currently we are working because we updated a lot of things. We think in different ways. If we approach this way, there is another problem we have to face. Maybe this is the better option. So right now we don't know what, but maybe around 5 lakhs something.
Which semester?
No, I am final year.
Graduate.
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 You both?
Yeah.
Graduate.
They are here wanting to convert this to startup.
Okay.
Okay, good. Good luck.
So this is the problem statement we have been addressed here. It is urban transportation system. It faces significant challenges due to the parking issues or due to limited last mile connectivity and high carbon emissions. These are problems being addressed in these situations like traffic condition and residues for limited parking facilities, environmental impact also like there will be zero carbon emission and accessibility issues also. So this is a solution what we have developed, that is a scoot like, that is a electric vehicle which is foldable and we can carry easily in parking areas also. And when there is traffic, for example, we can take the example of Bangalore itself. If there is like traffic for 100 meters or 1 kilometer, we can just fold the vehicle and we can carry for next after the signal. So we have developed a vehicle that is like 16 to 17, 18 kgs of weight. We have used aluminum as material.
Hello, myself Hassan. I'm going to explain about the design of the foldable TV bike. Mainly we use aluminum frames because aluminum is lightweight. This is a frame design. Actually we are not used steel, only for aluminum. Next, folding mechanism. It is a quick and easy folding mechanical, and we are integrated a battery 18,650 with a capacity. and we are using the electric motors with 2 motors are used. This is the technical specification for foldable bike. The battery capacity is 18,650 lithium battery we are used. The battery charging time is 3.5 hours. The minimum capacity of EV bike is 7.8 hours. And we are used a motor for 250 watt brushless and tubeless motor. It is 680 RPM, and I already explained to friend. It is a lithium material, aluminum material, and we have other components including folding mechanism, weights, and accessories. This is our scooter design. This is a
Actually, this is a two-wheel design, but we have included another wheel. But we had faced some problems before, so we didn't include that design. It's just a two-wheel design. So we have many traditional bikes, also the petroleum bikes also, then electric bikes, electric scooters and cars. We have disadvantage in that also, like we cannot carry from one place to another. It's like weight of like more than 60, 70, 80 kg. Our solution and our scooter is like I said you 18 to 20 kg like that nearly. But we're trying to build that. We have been funded by that is rupees 1 lakh. We have been utilized 50,000 for just chassis design. Now for next bench we will be designing the total frame of the scooter. So I said you that they have used many steel frames and all in other electric scooters. It's a bit heavy and it is like bulky design. We have a simple design which can fold easily, and we can even we can keep it in like cars and all. We can use it as a trolley system like that. How we use in supermarkets and as a trolley. We can just take it like that. This is the go-to-market strategy. Market research already. So next is a unique selling point of our value proposition. Then business to B2B partnership. Then same simple
Estimated price, market price. Around 1 lakh. At what stage you are?
We are design chassis now. Just we have got the funding like 1 lakh to design chassis now. Next we design the frame and other fittings and for next range.
What challenges are you facing right now?
Select the material.
Weight. So what is the solution to that? Any alternative?
So we used starting we thought of doing it from like maybe iron or steel like that. Then we came to solution that is aluminum. So little costly, but we are mainly focusing on lightweight. So we used aluminum there, and the braking system and all, and the folding method we are facing some challenge. We need to work on that.
Yes, ma'am, please ask. I will be there.
What are your suggestions towards their development of
Suggestions towards them is to go for high-grade mild steel, which is typically used in aerospace. They have asked for additional funding also. So
then it will cost more.
They have asked additional funding of 1 lakh more. So in that we can make the chassis because the design is ready. Foldable is also, retraction was problem. So now retraction is also happening. So because design is ready, we can go for another material with that given 1 lakh. That was my suggestion. Electronics, it is just get it and fix it.
How about hilly areas? Can it go there?
As of now, our focus is not on hilly areas, it is for
Plain land.
Plain land,
Straight
especially
land.
metropolitan cities.
Okay.
So if you are there in traffic
for
also,
traffic.
you should not stand there, park your vehicle, walk and go. That is the main USP for this.
In that case, you should concentrate on weight also.
Yes, that is the reason that high grade mild steel is one option that we are having. It's used in aerospace, it's very lightweight, but we were facing lot of issues with the design. Now design is okay with aluminium. So if we can make it with mild steel, then I think they have a good future in that.
So all the best for you.
Done. We'll distribute the certificates. Yeah. No, participant certificates. External first one.
ಹುಡುಗರು ಇದ್ದಾರೆ, ನೀವು ಒಂದು ಪೇಪರ್ ಹಾಕ್ಬೋದಾಗಿತ್ತಲ್ಲ.
ಅಕ್ಷತಾ ಇನ್ನೊಂದು ರಂಜಿತಾ ಅಂಡ್ ಅಕ್ಷತಾ ರೈಟ್ ನಿಮ್ದು ಆಯ್ತಾ ಸರ್ಟಿಫಿಕೇಟ್ ಆಯ್ತಾ